All right, folks, I'm gonna start my little bit right now. Welcome if you're here in the chat. We're 2 minutes after the hour and we've got a whole ton of people who are coming in through reception. Just wanted to welcome you to this OpenShift Commons Gathering that we do at KubeCon every time. And we're thrilled that you're here and sharing some of your KubeCon time with us. So really today is really about unlocking the potential of OpenShift Commons and making sure that you get the most out of today. I'll be here in the main stage moderating all day long, and Stu Miniman will be in track 2, being my co-moderator for that track. So we're just gonna motor through here. Really what we're trying to do today is take open source and open communities and open collaboration to the next level by creating some connections that will hopefully drive some continuous innovation into your organizations and into the open source projects that we're all working on together in the CNCF and in other foundations and other spaces. And OpenShift Commons, if you haven't joined us yet, we'd love it if you would. Our goals are really pretty simple, is to promote peer-to-peer interactions through events like this gathering and weekly briefings and all the interactive groups that we have. We have a pretty active mailing list and Slack channel. And of course, we love it when you contribute code to any of the projects that are part of the OpenShift ecosystem, because it's really about creating connected communities. It's no longer about just trying to get your code into our systems. And it's really about building connections across all of the OpenShift communities, the upstream ones, between stakeholders, and really Commons is the place for your organization if you're using OpenShift or working on the projects to accelerate your success. And to do this, we all act as resources for each other and sharing best practices and create forums like this one today to share information across all of the different organizations and projects and product groups that are part of Red Hat and our partner organizations. And we have over 600 member organizations already in the OpenShift Commons. And if you'd like to join, the URL's there at the bottom. It's really easy to find us on commons.openshift.org. And today's agenda is really for end users by end users. And it's going to cover 3 main areas: release updates, roadmaps, and beyond are really going to make up the bulk of our first couple of talks. They're going to have some deep dives into the latest release of OpenShift. And then we're going to have a peek at the future with Clayton Coleman and Joe Fernandez around the future of Kubernetes as a control plane. But the bulk of what we're going to talk about today are case studies from folks like Anthem, Discover Financials, and Rohde and Schwartz, talking about their implementations of Kubernetes and OpenShift and the different workloads that they're running on them. But we have a lot of great talks by end users giving us insights into what they're doing in the upstream. So you're going to see some deep dives into the RHEL container tools today. And then you'll also see some interesting talks about OKD, the OpenShift open source Kubernetes distribution. We have a great talk from Anthem about their use of Spiffy and their new initiative around Health OS. And we even have a great group of folks over at ODC Nord who are going to be talking about Submariner. And we do have a code of conduct. We're following the KubeCon EU code of conduct and the same one we use for all of our co-located events. And we're really dedicated to providing a harassment-free experience for all of the participants in our things, whether they're in person or virtual. So please be kind and be professional and use whatever your employer's governing appropriate workplace behavior and applicable laws are. That's really the key of today. So we have an interesting setup today. We're using a new platform to some of you. So this is called Hopin. The first main stage will be this welcome that you're hearing from me. I'm Diane Mueller, and I'm the Director of Community Development here for the Cloud Platform BU and OpenShift, and one of the co-chairs of the OKD Working Group. And we've got 2 great talks, one by a group of product managers talking about the latest release in the main stage. And then what we're going to try and do is answer your questions with the speakers via chat, and the Q&A tab in Hopin. And if you need support, please go to reception. There's a few folks waiting for you there. And then after we finish that, we'll pause for a minute. You'll see my face come back on again. And then we'll be streaming from the main stage everything that's listed in track 1. And then in track 2, you'll find my cohort and colleague and fellow moderator, Stu Miniman, who you may know from theCUBE, and who will have lots of Star Wars jokes because it is May the 4th today. And then we have a number of other wonderful case studies as well there. And so that's what we're really going to do today. And we're a few minutes off already. So let's get started. I'm going to start now and try and kick off the first of our talks with a few of our product managers. So stay tuned while I get ready to cue that one up. And hey, Rob, welcome.
Good morning. I guess good afternoon.
Good afternoon, wherever you are, yes. Now, this doesn't.
All right, hi everyone. Welcome to the OpenShift Roadmap update for 2021. Thank you for joining us at OpenShift Commons. I am Rob Slunsky. I'm joined here with Michael Elder. I want to say hey. Hey everybody. And today we're going to talk about what's going on in the OpenShift universe for this year. We're also joined by Jamie and Nina, who are going to pop in and out and give us some demos of some cool stuff while we talk about that universe. So I want to roughly set up a conversation to be around some.
All right, folks, I'm just going to restart that.
To the OpenShift Roadmap update for 2021. Thank you for joining us at OpenShift Commons. I am Rob Slunsky. I'm joined here with Michael Elder. I want to say hey. Hey everybody. And today we're going to talk about what's going on in the OpenShift universe for this year. We're also joined by Jamie and Nina, who are going to pop in and out.
Okay. All right, folks. We're having a few technical difficulties, so hang on. We're going to restart and see if we can do this. And I'm going to share my screen again. Welcome to the world of multiple videos. Share audio button, that's what we were missing.
All right, hi everyone. Welcome to the OpenShift Roadmap update for 2021. Thank you for joining us in OpenShift Commons. I am Rob Slunsky. I'm joined here with Michael Elder. You want to say hey? Hey everybody. And today we're going to talk about what's going on in the OpenShift universe for this year. We're also joined by Jamie and Nina, who are going to pop in and out and give us some demos of some cool stuff while we talk about that universe. So I want to roughly set up our conversation to be around something that we just announced in May of this year, which is OpenShift Platform Plus. And that really is bringing the OpenShift platform up a layer into the multi-cluster arena, realizing that you need multi-cluster security, you need a global registry, and you need multi-cluster management to be successful in today's hybrid cloud world. And so we're not going to focus on the actual product today, but we're going to talk about all the different pieces of that, what's going on in those upstream communities, and some cool features along the way. So I want to talk about this idea of standardized tools because, you're not just running 1 or 2 clusters, but you're going to run, maybe 100 clusters. And getting tools and policy and management down to those clusters is extremely important because, today's applications are spread and more distributed than ever. Clusters are more connected than ever, and that means that you've got to get that fabric orchestrated correctly. So we're going to talk about all this stuff, some of the tools that are available upstream in both Kubernetes and other ecosystems. So it should be a pretty interesting day. And you're going to see these two icons as we go through this parachute guide. That's when we're going to zoom all the way down into a single cluster because, what's happening on a disk of an operating system or a policy that makes its way all the way down into the nitty gritty is just as important as zooming all the way up back into that multi-cluster world with this rocket ship. And, the work that we do for fast packets for maybe like a telco workload is beneficial to your application, even if you really are up at the multi-cluster layer. So you got to build all these capabilities up, and they're all important up and down. So let's jump into it. Security, what's happening upstream? Two main things. First, with the version 1.21 of Kubernetes, pod security policies are deprecated. Now, this doesn't mean that they're going to be removed yet. I think that's going to happen in 1.25. But a few things to note here. The replacement for this is probably going to be a little bit more simple than what you've been used to. And so complex users might like some of the features of the Open Policy Agent. We're going to talk about how that fits into some of our tools later today. And you can run that today on OpenShift just fine. And then, of course, OpenShift SCCs, that's a security context constraint, are unaffected by this. This is kind of what pod security policies were modeled after in the beginning. So we kind of had your back before, we got your back now, and we'll have your back in the future too. So one of the cool parts about innovating inside of OpenShift directly. The last big change is user namespaces. This is kind of a kernel level construct that's made its way into Linux. And together with SE Linux, that helps protect your namespaces from each other on the cluster. Now, I don't want to get into too many of the technical specifics, but in the CRI, which is the runtime interface for Kube, this is now there. And so this is the default for talking to runtimes. With Cryo, what we use in OpenShift can do the user ID mapping in and out of the container, which is what actually is doing that user namespacing. So we're waiting on Kubernetes to roll that out, and then that's going to make its way down into OpenShift as well. So the proposal there, the KEP and upstream parlance, is still moving forward. Some of our engineers are pushing that, so that's one to take a look at when that comes down. All right, another big news in kind of the upstream arena and Red Hat world is advanced cluster security. This is based on our acquisition of StackRox. We're super excited to have these folks join the Red Hat family and build this into OpenShift and OpenShift Platform Plus. So we're starting the open source process right now for all the StackRox tools. And we're really excited about this because it's the most Kubernetes native security product out there. We're going to talk about some of the cool features and see a quick demo of it in action. But it really talks about this idea that you've got to secure your entire supply chain from, this shift left into where you're actually building code and building containers, into when they're actually deployed, and then actually after they're running. Malicious things can still happen even if you pass a container scan, for example. And so what this does is it has a combination of watching host and cluster state through some cool technologies. If you've heard of eBPF, this is kind of the Swiss Army knife of doing some like host probing into what the kernel is doing. So we take advantage of that, plus at the kube layer, admission controllers, looking at the audit log and some other cluster events, as well as your typical image scanning. So we're going to see a really cool demo of that in a second. So let's parachute on down. What does this look like in a single cluster? So I talked about runtime security as one part of your kind of threat matrix here. And this is a new capability for OpenShift, completely new. And what this looks like is, let's say we've got a pod and it's got Python in it and we got an application. And there's a vulnerability that gives you some local execution rights inside of that pod. If you're going to move left and right around in this environment, what you need to do is have some tools. So you might pull down a netcat binary and then start using it to wreak havoc. So here you can see how that actually works because you're going to go down into the kubelet when you're running your Python, but you're also going to run that netcat. And an eBPF probe by a security sensor that's installed is actually going to block that pod from executing that netcat. So this means that that binary can't be run if it matches your policy, but it's also going to protect network traffic moving left and right as somebody wants to exploit other applications that might be on this environment. And so we're going to look at a demo, and so I'm going to hand it over to Jamie for more.
Hat team. Welcome to Red Hat Advanced Cluster Security. or as we call it, ACS. To set some context, this is the cyber kill chain. It ranges from reconnaissance, which is understanding your victim and the system architecture, and what you're doing when you're trying to attack based on your objectives. In the world of security, there's a reason that there can be anything from denial of service, stealing data, installing crypto miners for financial gain, or really just because you can. The U.S. Council of Economic Advisors estimated that in 2018, that malicious cyber activity cost the U.S. economy between $57 billion and $109 billion in 2016. Since 2016, it's only increased. So let's think about this in terms of an onion, or defense in depth. Security should always have layers to it. There are many spots to spot attackers along each part of the kill chain. Today, we're going to focus on reconnaissance through exploitation. First, in the cyber kill chain is reconnaissance. We're going to find out everything we need to know about the application to start to exploit it. Then we're going to search for vulnerabilities to weaponize, create a backdoor, and deliver our exploit to get it up and running. Attackers afterwards will frequently look to establish a foothold in their position by installing malware, attempting to escalate privileges, and establishing a command and control server. So this is ultimately going to get them to the core objective, which can really vary based on their needs. Containerization as a movement has really helped the security team. Containerization has just isolated our attack surface. It's taken post-exploitation activity and made it harder to move through the environment because our containers are self-isolated. This has only helped the security community, and now it's time for this community to take advantage of it. So today, I want to walk you through the anatomy of an attack from a defender's perspective and that of an attacker. As a defender looks to investigate an issue, protect against reconnaissance through delivery, and monitor for exploitation. I also want to show you an attack as it could happen in the wild. So let's get started. So I'm going to transition over to advanced cluster security here. And as an incident responder, I want to check the violations. Now, I'm going to search right away for Visa processor. And as I look at Visa processor, I start to get concerned. I can immediately see that a shell was spawned by a Java application in their environment. And this concerns me. So I want to investigate further. I click on it, and I can see the gel command and the bash command were executed with several different arguments. I go down, I start looking at those arguments, and I can see really clearly here the container ID, the user ID, and that this user is escalating their privileges. They are installing netcat, and then they're using netcat to initiate a reverse shell in their environment to shell.attacker.com. Well, at this point, I'm reasonably confident that we've been attacked. I'm starting to initiate my incident response procedures, and I've lit up the SOC. And for those of you who don't know, the SOC is the Security Operations Center that's responding to these types of incidents. But right now that I'm initiating this procedure, I want to get more context. So I want to see how is it that someone has a reverse shell in my environment. So I go over to the deployment and I check out the container configuration. And immediately as I look at this, something jumps out at me. The CVE data may be inaccurate. So this base image is literally so old that the source is no longer providing updates. So you can see here, we're on Debian 8. This is no longer maintained. So we can also look and see, oh my gosh, this is Apache struts. So one of the top riskiest components is strut, which was a headline vulnerability in 2017. This was the cause of the Equifax breach. And I know that someone is initiating a Java reverse shell. So at this point, I'm reasonably confident that someone is exploiting struts in order to get into my environment. So I need to address this. Let me switch my persona to the developer for a second. So I scroll down. I have a ton of image findings. I can see the CVE. I can see how long it's been in my environment, if it's fixable, and its CVSS score. And this is really cool information, but as a developer, this isn't enough for me. So I'm going to go over to my Docker file, and I'm going to check out where these CVs are. So as I look here, I can see the components associated with my image. I can see that there are several CVEs. There are 137 CVEs in what appears to be my base image. And in order to address these, I'm going to have to upgrade my base image, and whatever CVEs are addressed in that upgrade, I will resolve here. I'm also going to check out my run instructions because this is where my application is. And I can see here, if I were to upgrade curl, then I could address several CVEs in curl. And all I need to do is modify this run instruction. So this is really cool. It helps me target where in my Docker file I need to address these issues, but it's still not enough. What do I upgrade my component to? So now I'm going to switch over to the component screen, and you can see struts highlighted here. So Apache struts has 10 fixable vulnerabilities. It has 38 vulnerabilities overall. And in order to fix those 10 fixable vulnerabilities, I have to upgrade to version 2.3.29. You can see its top CVSS score is a 10. That is terrifying, and that's a critical vulnerability. You can see the location of Apache struts, and you can even see this component's used in 4 different deployments. This might not be the only place that I need to address this. So one of the cool things about this view is that you can see struts is a Java vulnerability. So this is a language level indication, and the remainder are packages installed on our host operating system. So that's really cool. I know exactly how to address this, but it's not in my traditional manner of addressing this. So Red Hat Advanced Cluster Security provides developers an easy tool in order to look at this information in their CI or on their local host and understand that this is something that they need to address. It gives them the context to address it so we can shift left and improve our return on investment in our vulnerability management program, which is ultimately going to address the need to prevent reconnaissance and potential weaponization. So that's really cool. But it's time to go back to our story about struts. It's time to switch to an attacker's perspective. What happens when someone is trying to exploit one of my applications? So here, I have a website running. Now, it's not always going to be as easy as saying, this is an image that's vulnerable to shell shock, please exploit it. But sometimes it really can get that easy. So I'm going to understand and conduct some reconnaissance. So I'm going to go over to the developer tools. I'm going to check out this website a little bit more. I'm going to refresh the page. I can see, oh, my server header says that this is based on Apache 2.2.22. Easy fix, guys. Let us go to exploit.db. We're going to search for Apache, if I can spell. And we're going to look through all of the vulnerabilities known to be associated with Apache. And now I can start selectively looking at things that are known vulnerable in the environment and start to understand. So if I click on the top one, you can see this is available in Metasploit, which is some solution that attackers use. I can easily just download this exploit and start to test to see if this functions within my environment. One of the really cool things about this is you can see that there's the code live. So we have pre-baked exploit code on the internet, publicly available in a database called exploit.db. And this has shifted the paradigm of how attackers attack, because no longer do you have to be technically elite in order to exploit major vulnerabilities. All you really have to do is know how to copy, paste, and read code, and be able to modify it somewhat to meet your own needs. Now, that's really cool. But back to shell shock. So here I want to show you an exploit of the shell shock vulnerability. Now, I'm a good attacker. I need to let these users know that their site is vulnerable. So I'm going to go deep into some subreddits. I'm going to find a good meme, and I'm going to exploit them to let them know that I care. Now, I could have installed a crypto miner. I can start to escalate my privileges, but I'm going to be kind. I'm just going to deface their site today. So let me go to the terminal, and I'm going to execute this command. And you can see here, all I'm doing is I'm defining an environment variable through the user agent header. I am exploiting shell shock by issuing some trailing commands, echoing for legibility, and I'm catting the index.html file. So here, at this point, I've got a shell. I can begin to move throughout the environment, but I'm just going to have a little bit of fun. I've already gone on some subreddits, and I'm going to deface their site. I refresh the page, and you can see quite easily, I is in your computer, I am stealing your data, we have pwnage, let's go. So that was really easy. And in reality, it can be that easy in the real world. So let's switch back to a defender's perspective. Now, if we go to ACS, we can see that a violation occurred really easily by clicking on the violations. And the top one here is what I just did. It's an unauthorized process execution running in the shell shock deployment. And if I look here, I can start to look to see, oh, this person is putting cat pictures on Reddit in my environment. That's really cool. Now I can initiate it. But you know what? If I had this in blocking mode, it would have been even easier. Advanced cluster security takes a different approach to blocking. We can now kill this pod. So if this deployment is running in a replica deployment, then immediately, once this activity occurs, I can kill this pod. My attacker's defacement of my website is then reverted back to what is normal. And I have alerted my security team. I've fixed my website. And if someone used this to install a potential backdoor in my container, well, I've removed that. That's really cool. I've instantaneously addressed several issues. So let's pretend for a second that I wasn't just defacing a site. A lot of you are looking in the audience right now and saying, shell shock is old news. Someone out there is saying, Jamie, that came out in 2014. This is super old. Why are you even showing us this? Well, to me, this came out 3 months after I started in cybersecurity. This was my introduction to major vulnerabilities. So I figure, why not make it your own? This is a real world example of something that happened to me. So this and server-side request forgery attacks could easily lead to a container compromise the exact same way I showed you today. If that container is privileged, then look out, because as an attacker, I'm going to go right for some authentication credentials. I am going to try to escalate privileges from there, and maybe I can even get my hands on a nice old kube config. And if I get my hands on a kube config, then I've got authenticated access to the kube API, and I can exec into a pod to start to laterally move, and maybe even install a backdoor or some malware. So let's try that here. So I have access to the Kubernetes API. I'm going to do an OC exec IT into the shell shock deployment, and I'm going to run the bash command. Wait a few seconds. And what is this? You can see here, I'm immediately blocked by an advanced cluster security policy. Now, that's really cool because I've effectively told the attacker, no, you can't install your malware, you can't exec into a pod, you can't get access to my resources through the Kubernetes API. Now, because containers are ephemeral, the ability to exec into a pod generally isn't needed. And it is sometimes for troubleshooting purposes, but in general, it won't be. And by being able to block and monitor exec commands, you should be able to set policies to monitor access to your container infrastructure. And you can also set an exception process through deployment levels to allow legitimate troubleshooting activity. So let's switch back to the UI for a second. You can see here at the top that this is an enforced action. My security team has been alerted that this was blocked. And we can look to understand more to see, hey, is this a compromised credential or has one of my employees made a mistake? So a few last notes about the advanced cluster security advantage. If I go to our policy sets, we come with over 676 out-of-the-box policies with reasonable security controls to help you scale security in your OpenShift environment. Our customers use these every day to improve how they operate within the Kubernetes and OpenShift ecosystem. We also help you understand and prioritize risk in your environment based on a holistic risk management strategy. So if I click on risk here, you can see our top priority is Visa Processor. As you look at Visa Processor, you can see this is vulnerable to Apache struts. It's probably been deployed in an emergency. It's got secrets in its environment variables, a ton of vulnerabilities. And if I even scroll down, you can see it's privileged. So I can go use this container and I can get to the host operating system and see how I can begin to laterally move. Now, I really hope you learned something about the attacker's perspective and the defenders. We're really excited to be part of the Red Hat team. And if you're interested in finding out more about advanced cluster security, want to request a demo, feel free to reach out to me or our team. Thanks, Rob, and back over to you.
All right, thanks, Jamie. That was great. All right, so let's zoom back up into the multi-cluster arena for security. So here's our diagram again. You can see that we've got our multi-cluster tools. And of course, the policies that we just took a look at, we don't want them on just one cluster. We want to get them down to all of our clusters. And it's not just maybe blocking execution policy, but it's network policy. It's CIS compliance. We're going to hear a lot more about this in the open cluster management arena. They've got a bunch of tools for this too. And then we're talking about hundreds of clusters here. They might be out on telephone poles and other places like that. So these are remote sites. They can be physically attacked. So we've got our file integrity operator and some other things to look at that host state and make sure that someone hasn't jumped on there and done some malicious things. And then, of course, we're all the way down at the single cluster layer. There is that node layer where we're installing these sensors and these agents and the probes that actually make all of this happen. And so it's really exciting to be able to have one place to enforce all of this across all of your clusters. Here's what it looks like in the user interface when you're looking at network traffic. This is a key part. Obviously, you're going to have applications that are talking to each other. And so you can get a good idea of who should be talking to each other, who shouldn't be talking to each other, and then enforce policies around that. Another cool thing that the team has built is actually recommendation engines for, hey, we're looking at your traffic, and this is a policy that we think you should have based on how these applications normally function, and then block things when they're out of bounds of that. Here you can see on the right-hand side a list of some of the policies. So a bunch of stuff, maybe you decide that you never want folks to run curl in an image because that's how you can pull down content. So you could block that. So there's a mix of best practices, some, kind of widespread things like looking for Heartbleed and other exploits like that, as well as maybe you just care about any CVE over a certain threshold that you want to block that or do something else. Sometimes you just want to audit it instead. So bunch of really cool stuff. Take a look for that coming in the open source as well as in OpenShift. All right, let's jump over to applications, and I'm going to hand it over to Michael.
All right, thank you, Rob. So I want to talk about what's going on in the upstream around just general fleet management. About a year ago, we brought in Red Hat Advanced Cluster Management, and we've been on the effort to open source all the components of that. So there's a project that is relatively new, relatively young, openclustermanagement.io. This is where you'll find all of the open source capabilities from the Red Hat Advanced Cluster Management product. This is really focused on bringing together some technologies that are helpful when managing the fleet, and also creating some novel and new technologies that help glue together all the parts. So in particular, simplifying the lifecycle for provisioning OpenShift clusters running on hyperscaler clouds in the data center on virtualization or on bare metal, simplifying the process of how we deliver and configure the fleet, and then also audit for compliance. Does it meet all of our expectations? It does provide some integrated capability with GitOps, but we've also been working on bringing in Argo as a provider of GitOps as well. And then a focus on an inventory of what clusters are in the fleet. How do I dynamically place policies or application content across them and validate that it's running correctly? If you look on operatorhub.io, you'll find a cluster manager and clusterlet operators. These are sort of the core building blocks. They enable us to have a cluster become a hub. We'll see kind of a picture of what that looks like here on the next slide. And then an agent, which can run, all of which runs as Kubernetes native pods. And as I said, this brings together a number of open projects as well. So in this architecture view, what we're really looking at is a view of the hub cluster, and you can see aspects like the API server that the hub cluster exposes. Virtually everything exposed to the API layer is expressed as a Kubernetes CRD, so you can read and write those like you would any kube native API. There's also a search index, which uses a data store to understand all of the parts of any cluster in the fleet, and allows you to search that and even look at relationships. and find how things are connected across the fleet as well. On the managed cluster, you can see the agent, that is that object called the clusterlet. And then there are additional add-on parts of the agent that enable features like search, application delivery, policy management, observability, and health management. And here you can see the links to the operators on Operator Hub IO. Now, when we think about cluster lifecycle capabilities, a lot of times we're still thinking about a bare metal host that is in my data center. We're thinking about a virtual machine. We're thinking about something in the cloud. As we see more edge scenarios where computing capacity is pressed further away from the data center, we have to think about how do we lifecycle those clusters and those machines. So something that will be available in the near term as a tech preview capability will allow us to take a piece of bare metal hardware that connects back. We're able to provide connects back to a control layer. We're able to provide an ISO to actually boot that host. And so think of this as a technician installs a piece of hardware in a cell tower in some offsite data center, small data center, maybe even in a vehicle. And that barcode scanner allows them to know, okay, here's the identity of this machine, this host, and then begin a process to link it either as a, turn it into a single node OpenShift cluster where the control plane and the workers, the workloads actually are running on the same host, or turn it into a very small cluster. This really is going to be a powerful way to deliver computing capacity wherever it's needed. And then each of these clusters, again, connect back into that control plane provided by the Advanced Cluster Management Kubernetes capability, which is backed by this Open Cluster Management project that I spoke of. Now, when we think about delivering configuration, on the next slide, we really will think about how do we express this again with a Kubernetes native CRD. And here's an example that's really important if you're doing any kind of networking sensitive capability, particularly for things like a 5G style workload. You want a particular operator to be deployed on a cluster. You want a particular configuration for that operator to be made available. So SRIOV enables some really powerful capabilities from a networking aspect within the cluster. This is on the right, a set of YAML and policy definition that says, I want a certain configuration to be enforced, validate if it's present. If it's not present, automatically create it. And this allows you not only to work with the SRIOV example, but to deliver any of the operators like the file integrity operator, the CIS compliance operator, along with your own configuration, like certain roles or role bindings, OAuth providers, identity providers, networking storage, etc. And so this is what you see as a policy that's targeting a cluster. If we take a step back and sort of elevate above the single cluster view, then what we really are looking at is a control plane provided by Open Cluster Management that is communicating with multiple clusters in the fleet and assigning configuration. In this case, there's a concept that we won't really talk about much here, but there's a concept of a placement rule that says match this policy to these members of the fleet. And that control plane is actually delivering those policies and configuration down and validating, do they meet my desired state? Now, if I think about this maybe in a slightly different view and I start to think about cluster lifecycle, on the next slide, what we'll see is there's really this hub that is the control point. It allows us to manage clusters that are running on hyperscalers. So whether I provision a Kubernetes or an OpenShift, along with allowing us to actually provision and create OpenShift on the hyperscaler clouds, and even on bare metal and virtualized platforms as well. And so what this really means now is that this hub allows us to have one central view of our cluster inventory, regardless of where that OpenShift cluster is running. This is a key aspect of the broader vision around open hybrid cloud. Now, what can I do once I have a cluster that's under management? So that means that I've got the cluster manager operator deployed and running on one of my clusters, and then I've got the clusterlet agent operator running on any cluster that I've either imported or provisioned. And so in the next slide, what we see, or excuse me, in this slide, what we see is I can deliver a set of governance and compliance capability across any member of the fleet. This is where we're integrating the compliance operator, which comes out of OpenShift, along with other community efforts like the Open Policy Agent. There's also capabilities to integrate Falco and have it delivered. We'll see new capabilities over time with advanced cluster security. What this means now is that I have one central location through the hub that allows me to manage an entire inventory or entire fleet. So this is where we think about sort of elevating the view. And if I, on the next slide, want to sort of think about what does that look like to an end user, to an administrator, to a security person, to a developer, even if I'm kind of validating how these clusters are configured, then what I'm really seeing is this concept of different policies that are applied. And here we see an aspect of categorization and controls, right? So I can link a particular technical control and say that this is relevant for data standard XYZ, whether that's like a PCI DSS, a NIST 853, or even an internal data center that's, data standard that is specific to your organization. For each of these, you can see examples where I'm simply auditing, is this policy in existence on a target cluster? And in other words, is this operator deployed and running? Is this operator configured? Do I have the role bindings that I want running in that environment ready? And so I can either audit, and in one case here, you can actually see there's also an enforcement behavior. So I can use this to do anything from configuring the cluster. I can also use this governance engine to drive upgrade behavior across the fleet for either OpenShift clusters that are connected to a source of images in a public way or that have a disconnected registry as well. So with that, Rob, why don't you take us through what's going on in the networking layers?
So there's a bunch of cool stuff happening in the upstream networking arena, and we're going to look at 3 of them that kind of come together to make some kind of next generation capabilities happen for us. The first is Submariner. This is a project for cross-cluster connectivity. And this is kind of like basically some IPsec tunnels and other kind of stitching together of a bunch of clusters so they can talk to each other. What's cool about this is you'll be able to do service discovery and other kubisms directly across that boundary. So it's really going to be easy to stretch applications across 2 clusters, maybe either do some failover, because, the first step is being able to talk to the rest of those members to either sync data, anything that you need to do. ACM is going to actually orchestrate this for us in the OpenShift world. And so that's going to be a really great capability when used with our next capability, which is Istio Federation. So this is the ability to connect multiple service meshes together. Now, if you remember, in the OpenShift world, not everybody has to use a service mesh. This is an opt-in on a per namespace basis. And so if you've got namespaces running on multiple clusters, you can connect those together, again, over that same bridge. So this is a little bit more powerful because you have a little bit more control over exactly how things are federated. And then you'll be able to stretch that identity between pods across that, which is what everybody knows and loves about the service mesh, among a bunch of other things. And then last, we've got a new API for Ingress. This is the Gateway API. You might have known this upstream as Ingress v2. That name has switched to Gateway. And this is a more expressive API than what we have today. So if you think about Ingress today, it's kind of a very coarse-grained kind of rule matching thing. And then it's up to each Ingress implementation to talk about how it handles sticky sessions and cookies and things like that. So this is going to have a much more expressive rule set. And that means that an OpenShift in particular will have a swappable way to move that out. So say if you want to use Metal LB on a bare metal environment to fulfill this need, you can do that, or then use some of the other OpenShift router components in other environments paired with maybe an Amazon ELB or a load balancer in Azure. So really exciting to kind of meet everybody's needs, and so we'll be tracking that upstream as it gets underway. Remember some of the use cases for this. It's kind of better than a stretch cluster. So we've got some customers today that like to, have a cluster stretch between 2 data centers that are, maybe a few milliseconds apart. This is just a better scenario because you'll have more failure domains there instead of stretching it across. And then just easier HA if everybody can talk to each other and share identity. This means that you can move dependencies from one cluster to another with, those other teams not even knowing about it maybe, which is really exciting. And then lastly, to securely connect to shared central services, if you've got a secret vault that's maybe run globally for your entire organization, or you've got a global registry like Quay. So kind of makes sense to make a little bit of that management easier if everybody can talk to each other. So let's parachute down into what networking on a single cluster looks like. And so if you'll remember, we have our Multis CNI. This is what allows you to map multiple network interfaces into a single pod. And the cool thing about this is it's all driven by kube. So, networking is typically done, you would think, at a host level. And so up-leveling it a little bit into the kube layer means that you can use all these other tools that we talked about to do policy enforcement, to push down those policies, to mutate things maybe when they're not working the way that they should be, and ultimately then make it really easy for the developers of those applications to use those capabilities. So we're going to build on that when we talk about our networking story. And so let's take a look at another more specific SRIOV example that we talked about earlier. And I want to talk about this in terms of two personas. So, cluster admins are going to be able to configure this hardware. So this moves packet processing into user land, which is really cool because you basically get line rate speed into a pod. And this is useful for things that might be decoding a radio stream, or you've got like a really high traffic API or something like that. You can get line performance. And so cluster admins can configure this on a nodes, maybe like a certain node pool, and then coming in with that ingress implementation for the gateway API, have it really, really fastly hooked up. And specify a bunch of config. But you as a developer that maybe just wants to start processing packets, you're just opting into this with an annotation, and you're saying, hey, I want to get a new interface inside of my pod. I don't really care about all the other stuff. Some cluster admin dealt with that. So it really frees you up to just get your job done with your packet processing. So really cool. And again, we're doing this all in a single cluster, but you'll probably want to do this on multiple clusters. And so let's take a look at that multi-cluster arena. We're going to shift gears a little bit to the Submariner project. And I want to just give you a little bit more detail about what this looks like when you have cross-cluster service discovery. Submariner is going to introduce a cluster set. Now, what this is a group of clusters that have a high degree of mutual trust, which means basically the same namespace on cluster 1 is the same as on namespace 2. It's owned by the same folks. And so what that allows you to do is then start exporting services between namespaces on different clusters. And there's two CRDs. Again, we're programming the Kubernetes layer instead of anything higher or lower, which is great. And that just makes it so that you are opting into sharing something. You're not going to share everything. And then for the service import CRD, this is where it gets really powerful, is you can consume that via Kubernetes API. It's another Kubernetes object. But what you really want to do is probably just use DNS, just like regular Kubernetes service discovery. And so that's what you can do. And so if you look at this DNS address, you'll see that instead of cluster.local, it's clusterset.local. And what this means is you can now refer to the global set of all of these pods with one DNS name. So you can imagine this becomes extremely useful for building your applications. And so that's just one more powerful thing that you can do when you orchestrate all your clusters together. And then last, we talked about service mesh running over the same IPsec tunnels. This is kind of what that looks like in practice. So you've got, all the way down on your single cluster, you've got all your sidecars, which are forcing traffic through your service mesh. And then it's going over this. And then remember, all of this can be tuned and deployed through the multi-cluster policies and networking that's coming down from both ACM and ACS. All right, over to you, Michael. You want to talk us through applications?
Absolutely. This slide is sort of the where do you come from, where do you go, right? So in this case, Argo is focused on the ability to deliver capability, deliver applications and other objects into the cluster. One of the neat new things that's come out is the operator-centric deployment that makes it really simple to get started with this in OpenShift. That's the OpenShift GitOps operator. And this is also something that can be configured and driven across the fleet using Advanced Cluster Manager for Kubernetes. With Quay, we're really looking at how do we make it easy to source the images that are going to run against the environment. So a central place for image scanning and integration for scanning from Advanced Cluster security to allow us to ensure that the images which make up the applications running on the fleet are properly secured. And there's been an upgrade from Python 2 to 3. It was just recently completed as well for that project. So if we think about applications within a single cluster, I can get started, particularly as a developer or a small development team, and I want to use a GitOps-centric approach. I can install the OpenShift GitOps operator, and then from there, I can see my repo getting delivered into that particular cluster. Now, if I zoom out a little bit, I can also think about Argo helping to deliver capabilities across individual namespaces on the cluster itself, or multiple clusters. So I don't know if you want to switch to the next slide there, Rob, for me. Thank you, sir. So in this view, what we're seeing is you've got an inventory of clusters. It's provided by ACM, or Open Cluster Management. We have been building integration to allow us to feed that understanding of the cluster inventory to Argo, and then we can use the application object from Argo to deliver applications and content across clusters in the fleet. Those applications are getting sourced, the images for the applications are getting sourced from Quay, and that's where we can ensure with the DevSecOps approach using advanced cluster security that the images that we're delivering have passed all of our security scans and aren't carrying any CVE. Now, within Argo, I can see a view of this. We can also sort of zoom out a little bit further and think about the view across the fleet within Advanced Cluster Manager for Kubernetes. And here, what I'm looking at is actually a view that represents a topology of the objects in my world. In the middle, I've got the set of clusters, and I can see a list of Foxtrot AP Northeast, Foxtrot GCP, Foxtrot US West. So that's an OpenShift cluster that was provisioned in the Tokyo data center for AWS, another one provisioned in the Northern Europe region for GCP, and another one provisioned in Northern California on AWS US West 1. But my application is getting delivered to all three clusters, and now I can sort of get a central view of what makes up the application. I can see things like the deployments, the routes, the services, etc. And what's also kind of neat, something that we're not going to go into a lot of detail here, but where we have steps that aren't programmable in Kubernetes that require some additional automation outside of the cluster, we can even bring in Ansible to drive that capability. A typical use case we find is when I deliver a change through GitOps or otherwise, I want to automatically open a service ticket. And so we can actually have an Ansible job drive the creation of the service ticket that allows us to track that a change occurred. Or maybe, as in this example as well, I want to drive the configuration of a load balancer that sits in front of the clusters, and maybe that load balancer isn't programmable through an operator just yet, so I can use that capability. So here what we've talked about is how we use GitOps as a methodology, how we ensure the security around the images that we're delivering for applications, how we can actually simplify getting started with a single cluster using that OpenShift GitOps capability, and how we can scale that out to many clusters, integrating both what we do for ACM, what we do for Argo, what we do for Quay. But let's talk about the next layer of abstraction. So Rob, can you tell us a little bit about what's going on with functions upstream?
Yes, absolutely. So as Michael mentioned, let's talk about, getting even one layer higher. So you've heard the word serverless before, and then maybe functions as a service. Let's talk about both of those and what they mean. So Knative is the serverless platform for Kubernetes, and it's the one that we're backing upstream. And it's got a few different components, serving, eventing, and I have in parentheses builds, because that's not part of the upstream, but that's part of OpenShift, and it's a big part of using a serverless platform. So if you think about it, serving is about connecting a container that's running with a request for that container. And this is what allows you to have this model in between where you can do scale to zero. This is a new capability, that's only really possible in this model. And you can also, instead of just scaling to zero, you can scale up on certain events or trigger different types of applications to do things based on events. That might be when a new image is uploaded, go resize it and store it here, that kind of thing, or serve web requests, doesn't matter what it is. And so embracing Knative it's a new way for gaining infrastructure scaling properties, but it's using all the same primitives that you're already building. You've got, an application with traffic funneling into it somehow, and, maybe reacting to a few things. But that differs from functions as a service. And this is kind of what I'll say in quotes is the true serverless. This is that developer focused, I want to just write a function of code and I want it to run and do this thing. I don't really care about how it's scheduled, how it runs. I just want someone else to figure that out, and I just want to run my code. So that's what lets you have really powerful developer agility, because that's all you care about. But that means that this is a new programming model. It's not just, fitting into that, slice of maybe how you built your Django app or something like that. It really is a different way of programming. And so Here at Red Hat, we think about kind of a developer workflow as an inner loop and an outer loop. An inner loop is kind of you on a laptop writing code, writing some tests, and then checking that into a source control. And then entering that outer loop, which is all your integration testing, getting it into the wider app and platform, and then ultimately deployed. And so what that means is we need new tools that function, intended, in this environment, which is like CLIs that are terminal friendly, but for building functions. So Knative has this KN concept, and that's a really great CLI to do this. We also need new CI/CD tools. You need to be able to test and make these synthetic events around the things that your application is programmed against, and that can be things that are hard to kind of simulate with a Jenkins job or something like that. It just doesn't work. And then because these functions are kind of running all over the place, you need ways to aggregate the logs, look at errors. So it starts to more kind of resemble like a mobile application that you have deployed out on hundreds of phones. The error cases there are kind of roughly the same. And so we just need new tools for this. And so Nina is going to talk us through kind of the current state for functions as a service and where that's going in a quick demo.
Thank you, Rob. Hello, everyone. This is Nina. And in this demo, I'll explain what it means when we say that we see serverless as a deployment model and serverless functions as the programming model. We will also see how we can leverage the Knative eventing component. So for writing the serverless functions in the local environment, we would need KN and Docker installed. We would also need an account on a public registry such as Koei and docker.io. I am in the directory where I would be creating my function. As you can see, there is nothing here. So to write my function, I would do kn func create prompt is for the runtime, and we will do Corpus, one of the hottest runtime, or I could use the C prompt for an interactive experience. It's asking which project path I want to do. I want to do the same. Node is the default runtime because this comes with a prepackaged runtime like Node, Corpus Go. We want to do Corpus. And the default invocation is HTTP for these serverless functions, but we want to use cloud events. So I am going to write events and see what the function has come up with. So the function construct has created the directory structure for me and some files. So if we can go there, you can see we have 3 classes. Function.java is where we would be writing our code, the business value that we want to bring. Now let's make this function do something, such as translating an English word into Spanish. So I will find my prepared code. Here, need a bunch of import, and in interest of time, I have copy pasted that too. Now, with the KN CLI, we could build an OCI image. Here, KN func build command. It is going to use build paths to create an OCI image. And now it is asking me for that registry. And I'm going to give Docker. Yes. To build a function image. It is going to use the build path to create an OCI image. As you can see, our function image has been built. Now to test it locally, all we need to do is kn func run. That our function image has been built using build paths. We test it on local. We're going to see that it's going to start the runtime, and it took us this many seconds. And to test it, we are going to send cloud event. At the cloud event, send it. The translated result is hello. Message we were sending is hello, and the translated result is hello. So now that we know our function is running successfully, it's time to deploy it on our cluster. So I log into my cluster, and I am in the project namespace where I want my project to be deployed, and all I need to do is kn from deploy. It is going to build my image again just to make sure that we have the latest, and then it is going to push it to the registry and then deploy it to the OpenShift cluster. Meanwhile, on our cluster, we would create an event source that is going to send cloud events through our function so that our function can translate that event. I am going to use this thing source, create event source. We're going to say message hello, schedule, let's do this. And if you see resource here, I am going to go wait till I get my function deployed here. This is our ocp.console. So if I see in our topology view, our function is coming up here. There we go. If we go in our add again, do the event source, thing source, root, there it is. And we're going to do focus on demo. See, our thing source got created, and it is sending events to this. And here we can see the logs. See that it's started up, and our ping source hasn't started sending events yet. There were no events received, so it was terminating. But then event came in, so it's starting again. So as you can see, it does the auto scaling for you. And here we go. We are connected to Knative events. Knative event source cloud thing. We are getting cloud event, and our result is the translation of the word hello. And that is all for today. I will stop sharing, and back to Rob.
All right, thank you, Nina. That was awesome. So wrapping it up, we looked at functions and how it works, but let's up-level it again. Let's zoom up into the multi-cluster layer. And as I mentioned, you'll see that we've got some layers here, but they're blank because you really don't care about this. At a functions as a service user experience, you're going to be maybe in an IDE, you're working with your CLI, and you don't really care about the concept of clusters. You just want it to work. You just want to run 5 or 6 copies of your thing, or if you've received 5 or 6 events, you want to spin up some copies of it. You don't really care which nodes it's running on, all that stuff. And so it's really a different and more powerful way of thinking about your infrastructure. But as we talked about, it does require new tools. So we've got a talk coming up after this where we're going to hear about this more in detail, where maybe I don't want to see any of these cluster details, but I want the same goodness of OpenShift under the hood. So stay tuned after that. All right, so I hope you enjoyed our talk where we parachuted down about the building blocks down inside of a cluster, and then we rocketed all the way up and saw how just important as they are to the fabric at the top of it, getting down clusters, taking care of security at every single layer, taking care of policy at every single layer. And so, these building blocks at the bottom, maybe if you've never heard of FIPS mode for encryption. If you haven't, that's good on you. But this is the type of stuff that it matters deep inside of the operating system, but it impacts us because we want all of our clusters to be compliant. And that's just one example of many. We talked about fast packet processing, mapping GPUs is another use case where all those building blocks span all these different layers, and it's really, really critical for being successful in a hybrid cloud world. So I hope you enjoyed it. Thank you, and we look forward to seeing you in the OpenShift community moving forward. Thanks.
Well, hello, everybody, and thanks for listening. Hope you enjoyed this morning's FUBARs with technical support. All of the links will be live post-haste. after the sessions are done, and hopefully in YouTube, some of the tiny fonts for the demo will be a little bit more legible. I'm going to queue up our next talk with Clayton Coleman and Joe Fernandez on Kubernetes as a control plane. Folks are going to hang around in the chat to continue to answer your questions. So without further ado, because of timings, I'm going to start that talk up, but keep asking your questions and join us in the chat here. Thanks, guys.
Thank you.
Share. And it did it again. It did not ask me about the wonderful and Chrome tab.
Welcome to our session, Kubernetes as the control plane for the hybrid cloud. This is going to be a more in-depth version of a similar keynote that Clayton is doing at KubeCon this year related to some work we're thinking about in the upstream Kubernetes. We want to give you a bit more context and connect it more deeply to the problem we hear from customers and how OpenShift Kubernetes are evolving to address those. My name is Joe Fernandez. I'm the GM of the Core Cloud Platforms business unit here at Red Hat. And my name is Clayton Coleman. I'm architect of hybrid cloud at Red Hat. I've been focused on Kubernetes and OpenShift for a very long time. You've seen some of my previous KubeCon talks. I focused on how boring Kubernetes should be.
All right, folks, I'm just going to figure out what's wrong with the sound again. Bear with me.
Welcome to our session, Kubernetes as the control plane for the hybrid cloud. This is going to be a more in-depth version of a similar keynote that Clayton is doing at KubeCon this year related to some work we're thinking about in the upstream Kubernetes community. We want to give you a bit more context and connect it more deeply to the problems we hear from customers and how OpenShift and Kubernetes are evolving to address those. My name is Joe Fernandez. I'm the GM of the Core Cloud Platforms business unit here at Red Hat.
And my name is Clayton Coleman. I'm architect of hybrid cloud at Red Hat, and I've been focused on Kubernetes and OpenShift for a very long time. If you've seen some of my previous KubeCon talks, I've focused on how boring Kubernetes should be, needed to be in order for us to all be successful. After a pretty crazy year, I feel like this is the perfect time to talk about things that excite me. Joe agreed that these are exciting ideas. Doesn't mean we're going to do them, but it means they're a way for us to think about where we want the future of our community and our project, and how we can deliver the most value for application teams and operations teams at the same time, which is really what Kubernetes has been about from the beginning.
Before we get into the details, let's just talk briefly about Red Hat's Open Hybrid Cloud strategy and what it's all about, and how OpenShift and Kubernetes enable that. All right, so Red Hat's strategy is Open Hybrid Cloud. It's something that we've been talking about for many years, and really our focus is on two key things. First, how do we enable enterprise customers to build and manage a hybrid collection of apps and services that span from traditional architectures to cloud native, to data analytics, AI, ML integrated, and beyond. And then second, how do we enable those apps to run anywhere across a hybrid infrastructure spanning from the data center to multiple public clouds and out to the edge? So OpenShift is our hybrid cloud platform, and it's built on a foundation of Kubernetes and Red Hat Enterprise Linux, but provides a comprehensive platform that enables enterprise customers to build, deploy, and manage applications wherever they want. If you attended our OpenShift roadmap session at Commons Gathering or any of the other venues, you saw a lot of our recent work has been around how we add new and better capabilities for managing multiple OpenShift clusters across multiple environments. Features that we're developing to help customers manage OpenShift and their applications across a hybrid environment are the same ones that we rely on ourselves to deliver OpenShift as a managed cloud service. So as you can see from this slide, OpenShift is available as a fully managed cloud service across all the major public clouds. And then we also deliver it as a self-managed software solution that you can deploy and manage yourself wherever you want to run it. But either way, Kubernetes is at the core of this platform.
Yeah, and I mean, 7 years ago, we began this project, we working in the community on a broad and expansive, vision for how containers could help make applications teams more successful. It was a really simple idea. It's orchestration of containers, a declarative API model. The API model is about intent, right? That's saying what you want and then making the machines go realize it, because we have other things to do. We gotta go write those apps. We gotta debug those apps. We don't want to be there telling the machines what to do every day. The machines can do that for themselves. We heard clearly, in the early phases from early adopters, we needed to bring new concepts in. Like declarative APIs are really powerful. Can we bring new concepts alongside all the ones that were in Kube? And that's been successful beyond our wildest dreams. And today, 7 years later, a huge number of organizations and companies and individuals run services successfully on top of Kubernetes in a way that it standardizes deployment. And so we need to ask, what can we do to move Kubernetes forward?
Talk about the evolution of Kubernetes over those last 7 years and how it's evolved to address customer needs. And this is just one way to look at it. I looked at it in terms of these 3 phases. So in phase 1 of our Kubernetes journey, the Kubernetes API and the core primitives and declarative resource controllers that are part of that allowed users to orchestrate an expanding number of application workloads. And we saw this with customers and partners alike.
Yep, and this is the evolution of Kubernetes has been driven by people putting it into use and then finding gaps and helping us identify, where the project as a group we could go. So Amadeus is one of our earliest Kubernetes clusters. They started using replication controllers for their long-running services, and this is in the days before deployments. They realized they also needed a solution for batch jobs, and at the heart of Kubernetes, we anticipated this, but through that community collaboration, Amadeus was actually able to help drive those features. It was the very beginning of Kube, and those features today exist as part of that collaboration in the community.
Cool.
And earlier, oh yeah, that's right. And also, before I forget, Couchbase, one of our key partners, also wanted to deploy databases and containers. This was a hugely controversial topic for the first 5 years of Kubernetes, and it was really people who were willing to believe that this was a better way to standardize deployments for all their applications. People who put the time in the community to make sure that these were reliable, and stateful sets, which themselves have gone through a long evolution, are there to support workloads that need to be predictable over a long period of time. And that was through, those kinds of collaborations that was possible.
Then in the second phase, you see here in the middle, we needed to expand beyond the Kubernetes API, right? And so operators and custom resources, custom resource definitions, which powered those operators, allowed users to extend the Kubernetes API to manage more complex workloads day 2 by adding customized automation that was specific to each component or each service.
Yeah, and early in the development of OpenShift, we made the decision in the Kubernetes community that we wanted to have a small, compact core of functionality that wasn't platform as a service, which it was about running applications. And obviously the scope of applications is practically unbounded. Working in OpenShift, we wanted to contribute these concepts and build them in, but we had no way to do that within Kubernetes itself. And so, over time, in partnership with a lot of folks in the community, that led to custom resource definitions and common controller logic, which have, now enabled and empowered a huge amount of extensibility over the years. Custom resources let us put the config for the cluster on the cluster. That's something that the kubeadmin project has used as well. So it's this idea that everything could be extended and you bring new concepts cleanly, really is a key part of Kubernetes. CoreOS brought kind of formalized and helped settle the pattern, which is it's not just the API and it's not just the controller, but it's the two of them together, and it's called operators. The operator pattern is really about hiding complexity, whether it's for deployment or for extending Kubernetes. And through the work we've done, that's been integrated back into OpenShift, and we've seen a huge uptake in the broad ecosystem of people extending Kubernetes with their concepts, and we think it can go further.
Yeah. So now in this third phase, we're thinking in terms of lots of applications spanning many clusters, those clusters spanning many different environments. And so really what we're trying to do now is explore, and we'll do that in this session, how can we better leverage that Kubernetes API to manage services across multiple clusters and have those clusters running across different clouds, data centers, and edge environments.
Yeah, and today, in a sense, we're continuing that extension pattern. We're bringing new concepts. We're doing it, depending on how you approach the problem. Some folks are building this out from their cloud console projects like Arc or Anthos. Within Red Hat, we've been actually thinking about this as, what if you had a hub cluster that was a little bit of your management cluster for all your other clusters? What are the extensions you want to add? The ability to create new clusters, the ability to run integrations that ensured policy was synchronized across those. And so, it's pretty natural for us to think of how can we add those new concepts in that make multi-cluster easy. As we've started to go, we know that that's not enough, right? There's always better ways to subdivide work. And so some of the learnings from the very early days of Kubernetes, adding new concepts that we never got around to, going in and building operators and the broad ecosystem of people plugging into Kube, and then this multi-cluster idea is, we started to look at this and we're kind of exploring how can we take some of those ideas and compose them in novel ways. And this is really early. Think about this as we don't even call it, I don't call this a project. It's definitely not a product. We're calling it kind of a prototype. It's a way to think about these ideas together that can help us look at the same problems we've been having in new and different ways. So I mentioned, Kubernetes standardizes deployment. We've kind of said, what can we do to improve security? If you've got all these clusters all over the place, there's a lot of duplication. How do you look for opportunities to separate out control planes from data planes? And how can you improve resiliency, operational flexibility? If you've got to install more and more stuff into the same cluster, you run into some limits. I think to a lot of people today, Kubernetes, the container orchestrator, Kubernetes, the declarative API, they may seem inextricably linked. I think that this is the simplest architectural slide that Joe and I could find of all of these concepts, and there is a huge amount of detail hidden here. But you think about these pieces, most of us think these are all part of Kube, but we wanted to come into this and say, well, what if we change direction? What if it wasn't about all these other pieces? It was about Kubernetes, the API. What would it look like without pods or services, without nodes or kubelets, without controllers or schedulers? So it's like, I like to call this talk, somebody came up with this the other day, is like nodes, where we're going, we don't need nodes. So that's my Doc Brown impression, and that's about as good as it's gonna get. So while I start sharing, Joe, if you can tee me up.
Yeah, sure. Let me just go back here. So while Clayton is sharing his command line, we're going to show you a preview again of some really early stuff that we've been playing with around these concepts. You'll see this again during the KubeCon keynote if you are able to attend that. But we figured we'd be able to go through it here a little bit more slowly than behind the scenes look, and then ask questions as we go. So hopefully, yes, we're seeing Clayton's command line, and we'll take it away, Clayton.
Yeah, and just to continue my my Doc Brown joke, we've gone back in time. So this is, you're seeing the future from the past. So just pretend like the KubeCon talk has already happened. You're getting a deep dive, and I promise you won't miss anything. So what would Kubernetes look like without pods? So this is the first question. So pretty standard command line. I run it. What if the server told me it doesn't know what pods are? Oh, okay, that's an interesting idea. What can I do without pods? So tried to boil down the list of all the resources in Kubernetes. You got namespaces, so you can subdivide your work. Different teams can collaborate together on similar but not identical things. You have RBAC, so you can protect your resources. Secrets and config maps and CRDs that lets you extend and lets you put generic data there. This is what we're calling a prototype of a kube-like control plane. Kubernetes API without pods, containers, nodes with extensibility, client support, and tooling that works today, right? Like if you see me using kube control here, what if we didn't have to throw away all of our tools and we could just take everything we have and move forward?
Well, let me stop you there. So if I understand you correctly, you're essentially talking to the Kubernetes API server with kube control as you normally would, but rather than having it deploy containers to a particular cluster, you're going to use the interfaces that it already has in order to create this notion of a hybrid cloud control plane.
That's right. Pure control plane, kube focused. It's the heart of the API. I can create and update resources, but the only resources there are the resources that help me. There's nothing that has to do with running workloads. It's just, what do I need to integrate anything? And so like this kind of comes down to is like, what can we do with this, to follow up on your question, Joe. So, there's a ton of integrations actually out there today that integrate stuff into a kube cluster, but that don't actually live on that cluster. So cloud resource operators, I got a couple of examples scattered in here. We actually shortened some of it so you can actually read it because everybody gets really long with their names. But I can create buckets or topics. I can create functions. These are all features that exist today in various operators and extensions. Sometimes you're dealing with multiple clusters and you need an integration that lets you, work. Say like, I want this cluster to expose this part, and then I'll go to my other cluster and install that CRD. And kind of one of these challenges is they all require you to know, which one owns it. So like if I had a database and it was installed on this cluster. Oh, well, I screwed up in the demo. Even in recorded sessions, demos are still unfaithful. But that database, I would still have to know where it is. And so we kind of asked the question like, well, a control plane could be the place where it all is. And that means that I don't have to think about which cluster to secure and okay to install an extension there. I can run the control plane and then my clusters are separate.
So you're basically taking all those Kubernetes primitives that we described earlier that came out of the first two phases of the project's evolution, users, roles, namespaces, controllers, and so forth, and really applying them in a different way, right? So you're now applying them to kind of manage services or apply to usage that really spans clusters and spans the users and the applications that run across those clusters, right?
Absolutely, yeah, and it's the basics of Kubernetes, but we don't think about them because we're always talking about services and pods. And so I showed like 10 examples getting installed here, and I think one of the challenges, and we see this today everywhere, is I install one extension, and I install another extension, and I install a third extension. The more I add, it's more concepts I have to keep track of, and so teasing apart those problems so that we're talking about them in different ways helps get a lot of things. So if I'm a security team or I'm the infrastructure team, I may not want to know about higher level integrations like this. That's not my job. That's not my role. And so if we can tease those apart, what are the things that would help us tease it apart? So one real challenge is multiple teams sharing a single Kubernetes cluster with something we've been exploring for a long time. OpenShift has spent a ton of time and effort and adding tenancy to Kubernetes, keeping teams apart, making stuff secure. There's a lot of different trade-offs. There's no perfect security. There's just what is right for someone at the time. And this, better or worse, a single cluster, I think, is still one of the strongest boundaries we have. So, if we're imagining a world where we have more clusters and we have that cluster as a strong boundary, it led to a real question that I think is super exciting, which is if instead of just having lots of clusters, if we could make getting one more cluster really, really cheap, would we still need to have all those big, physical clusters? And Joe, we talk about this all the time. It's a key challenge customers have.
Yeah, definitely. You're highlighting a challenge that that we've been talking to customers about for years. not just OpenShift customers, but Kubernetes users in general, which is how do you manage tenancy across your various developers and teams, right? We saw this from the earliest days of OpenShift 3. Customers would start with a single cluster, would start with a small team, and then inevitably that would grow. And we did a lot of work around, multi-tenancy within the cluster to address that, right? So, if you saw where Red Hat invested our resources, it was into evolving features like namespaces and quotas and roles-based access controls. And then even additional concepts beyond Kubernetes, things like the multi-tenant OpenShift SDN to segregate application traffic. We worked then on network policies and more. So despite these capabilities, customers always found requirements that would call for creating yet one more cluster, right? So all the tenancy in the world doesn't eliminate the need for multiple clusters. And then as the number of OpenShift clusters grew, so did the need for more multi-cluster management. And we already discussed that earlier. That's really what's driven our roadmap recently around bringing in better multi-cluster management capabilities. But it sounds like what you're talking about here is how can we make it easier to just ask Kubernetes itself to give us clusters when we want them, and then make them available for what we need them for. Is that right?
Yeah, absolutely. And this is a little bit mind-bending, and I think there's a lot of things that we're still exploring, but there's a hard limit in Kubernetes. If you want to tease apart all your different extensions and people still need to run in that environment, you still have to install the CRDs together. There's no tenancy for CRDs. So it was really obvious. It was like, okay, we've got this control plane that's really stripped down, and we're adding CRDs to it to make it something that people can work together. So I'm going to show you here, I'm connected to my local control plane prototype. And I'm going to show, as you can see, the URL that we're connected to from kubectl. It's my local server. We're going to switch to a different context that's provided. The prototype generates a kubeconfig file that actually points to two different clusters. So they're called the second one user. And when you look at the config line, what you'll see is the URL is different. And so it's the same server, but I've got two clusters. So there's the first cluster that I did all that, the showing you didn't have pods and I installed CRDs into. But in this second cluster, if I call get databases, it tells me it doesn't have any databases. And that's because the different clusters see different CRDs. So if I call kubectl get CRDs, there are no CRDs. So in a sense, the database from the other cluster is invisible. The new tenant can't even interact with it. That's a pretty hard security boundary. So like two different teams on the same, they're talking to the same server. Under the covers, maybe there's some stuff being shared, but to each individual team looks like two completely different clusters. So like there's a lot of possibilities in here. Imagine instead of one cluster with thousands of services, what if we had thousands of little clusters, each running one service? What are the things that we could change development-wise and operations-wise that, starts to split that problem up?
Yeah, it's pretty interesting. It also aligns with, some of the work we've been doing lately around getting smaller clusters, right? So we've seen that related to customers who want to run Kubernetes at the edge, which we've been trying to enable with OpenShift, whether that's in a 3-node cluster configuration, a distributed worker node, or even single node clusters. We're also doing some of that work with the IBM Cloud team around a project which we've called Hypershift. And Hypershift is a project that allows you to deploy Kubernetes in a managed control plane model. So what that means is you have a central management cluster, it's running control planes for a bunch of other clusters, and then the end user clusters are literally just the nodes that they bring to the party, essentially. So, the cluster could be just their one node and they get assigned a control plane. So kind of lots of interesting concepts that have been coming up lately around, how do we make these clusters smaller? How do we get more of them? And it's kind of interesting to think about in this context when you try to, when you're saying, let's flip the view here and think about, thousands of applications, thousands of services, each in their own little cluster versus, putting them together. Is that?
Yeah, and there's a bunch of advantages, like split control plane and your data plane. You keep all your your high level logic on the control side. So like if you could have a control plane for applications, you don't need a ton of stuff. And actually, I'm going to show like a couple of examples here. But if I have to even get to the point where we could do this, well, I need I want to have thousands of applications, but if I can't bring all my existing applications, it's going to take a while. And, it'd be really painful. So like a big idea for this prototype is, how can we bring as much as possible of Kubernetes forward without having to change everything? So, what if we could connect our control plane to existing clusters? So you can turn Kube, the API server, the lightweight control plane, back into Kubernetes, the orchestrator. So I've got a little CRD here, and it is it's just pointer to a cluster. It's got a kube config as well, and I got a secret in there that I'm not showing. And then I'm going to apply that to the control plane. And so that's, oh, okay, it looks like one of those bugs. Okay, so it applied the resource and it's created. And so now I've got this created, and I'm going to go ahead and create a second one because, if you just have one cluster, it's not a really good demo. So we'll do 2 clusters. Bet you're going to get the same error again. Yep. So it went and created the clusters. There's still some bugs. I said it was a prototype, right? So by installing this cluster, what have I done? Well, what I've done is I've imported from those clusters all of their resources as CRDs. So I didn't need to implement that other cluster's handling it. So just like we added those CRDs for external integrations, what if Kube was an external integration? So I'm going to, now that I see, you can see deployments are in this list. Actually, let's scroll back up. Yep, deployments are up here. And so I have a deployment and I asked for 15 replicas, and it's connecting to 2 local clusters. And I just run kube control apply deployment against the control plane, and it goes and creates it. So if I call, get deployments now, you'll see it. If I'm going to wait and wait and wait and wait, and this is local, it's kind of fast. So, if I do it, I see those resources get created. So I had a simple controller here, like that split it up, right? So we created the one, and then it was like, hey, like, what if instead of just, running just the deployment, what if we had a little controller on the control plane that would split them up and run them on individual clusters? And some of this is like pretty prototypey. We're still just kind of hacking this together. But the idea would be that, you define your app, you take the apps that work today, you stay on the high level details. Instead of getting down into the weeds, like, we want to focus on deployments and services and integrations with databases. I don't want to be dealing with this low level. It's like we've kind of come full circle, from Kube to API and then back to Kube. But maybe what's different this time around, this is kind of like the big idea, and that's why the prototype was so exciting to me, is, what if we just didn't add pods back, right? What would it mean to have a Kube without pods? Like, we've been doing this for, 7 years. I've got this fully running application. It's got these other clusters out there doing the hard work. Maybe 7 years into Kubernetes, like maybe that 4th step in the slide that Joe showed is like, maybe we should be thinking about applications, like pods, nodes, clusters. Those are details. Let's think about applications, services, how I glue things out. And that, to me, that's hybrid, right? It's connecting all the different things, not just pods and nodes, but all of my application in any cloud, in any environment, on-premise, hosted, service or not, like trying to pull that together. And I think this, I think some of these ideas could be pretty instrumental in getting to that point.
That sounds awesome. And that's how you start turning Kubernetes into a hybrid cloud control plane, right? So how can people learn more about this? Where can they go?
So tomorrow, when and I think this is the session before, the day before KubeCon. So my talk out tomorrow, we'll publish the repository, and it's github.com/kcp-dev/KCP. And KCP is just this is a prototype. KCP is an arbitrarily chosen acronym that has nothing to do with anything about Kubernetes or control planes. It just looks that way. We're really thinking about this as like the seed of a bunch of ideas. We want to see how those go. We're not too opinionated at any point here. Our goal really, I think, as Joe said, is like we're trying to bring together these ideas and really move the conversation forward. So I'm excited to be here. I hope everybody loves these concepts. Please reach out to us, and I hope everyone here does have a great KubeCon. And please watch my much more compact talk now that we've given you the insider's preview to it.
Awesome. Well, thanks everybody, and thanks for joining our session.
Hey, folks, welcome back. And we have Joe and Clayton here, and I just want to thank them for joining us here. You can turn your faces on, and we had a bit of a 10-second delay there. So let's just see. There we go. Hey, Joe. Hey, Clayton. I'm not seeing any questions, so I think you've blown everybody's minds, and I'm really looking forward to seeing the folks on the stage on KubeCon tomorrow. We're running a little bit behind. Joe and Clayton, if there's any final words you'd like to say, anything, since you did pre-record it there, has the world changed in the past week? And is there anything you'd like to add now?
Can y'all hear me?
Yep.
Yeah, there's not much that's changed since last week. What we're trying to do is, and I mentioned this in the chat, is the repo is not live yet, and the repo is very much about the prototype, and there'll be some extra docs in there that kind of go through these concepts. This is a very early stage. We wanted to start in kind of the where could we go and show a bunch of ideas together without getting locked into, this isn't a project yet, and it's definitely not a product. But for Joe and myself, as we were talking about this, is we think it's really important to people build platforms on top of Kubernetes to run their enterprises. That's what hybrid cloud is. There's certainly other pieces of that world that aren't Kubernetes. For us, bringing all this together, giving people tools that move things up a level. Someone in the chat called this stateless clusters, and I'd actually like to call this serverless clusters, right? We want to get to a point where when you build applications, you can put a layer between you and the physical infrastructure, whether that's cloud physical infrastructure or on-premise infrastructure or edge or your local laptop. So we are definitely trying to kind of create a center of gravity for bringing all of this stuff together.
Yeah, I'd just add a couple things. First, in the roadmap session, you heard a lot about advanced cluster management for Kubernetes from Michael Elder and Rob Zumsky and team. We think that that's a great solution to manage a multi-cluster environment today, cross-cloud, cross-environment. And what we're working on with this KCP prototype and some of these things that Clayton's been experimenting with upstream with our team is, how can we take it further and do more, around the Kubernetes API itself to better enable being able to work across these types of hybrid environments. There's also a question on Hypershift, which I mentioned. Hypershift is a separate project. It's not dependent on KCP or related to it, but it's for folks who are interested, I dropped the GitHub link. It's basically a deployment model where the Kubernetes control planes run on a central management cluster, right? So you have an OpenShift cluster. It then has namespaces. In those namespaces would be a control plane for a separate end user cluster. So if you have 100 namespaces, you'd have 100 control planes. Then the end user clusters essentially are just the worker nodes that get spun up and then they claim or get connected to a control plane. So we're evolving that on its own. The IBM Cloud team uses it. That's how they manage OpenShift on IBM Cloud. I think other hyperscalers do leverage similar approaches for sort of centralizing and managing control planes. So it's not dependent on KCP. It's something that we're already using in OpenShift on IBM Cloud, and we're going to be bringing it to other environments. But it could potentially come together with some of the concepts that Clayton described in this KCP prototype, and interested to see how that all comes together.
There's a couple other questions in the chat, and we are running a little bit behind in time due to some of the technical snafus here. But suffice to say, Clayton and Joe will be around in the ground answering questions. And we're going to kick off another talk here. If Clayton and Joe, I think you can both see the Q&A. So if you want to just answer those questions, and I will queue up our next talk, which is with Discover Financials. And they're going to talk about some of the work that they've been doing to streamline the OpenShift developer experience, building an enterprise Helm chart repository. I did mention in the opening statement, Gambit, that we're going to hear a lot about from the end users on how they're using different pieces and parts of different upstream projects. And this is quite an interesting one coming up too. So thanks, Joe and Clayton, for taking the time to come and chat with us. Much appreciated. Everybody looking forward to the 5 minutes of fame that Clayton is going to get on the KubeCon keynote stage shortly. So we'll make this video available as soon as today's gathering is over and tweet it out so that you can watch it and pepper him with questions on the KubeCon stage as well. So please feel free to share the link as soon as this event is over. So with that, I'm going to see if I can get my other speakers in here, and I'm going to queue up their talk while I'm doing this. So hang tight, and here we go. Try this again. And here we are. Share the audio.
We're talking about streamlining the OpenShift developer experience by building a enterprise Helm chart repository. My name is Austin Dewey. I'm a senior consultant at Red Hat. I've been with Red Hat for about 4 years, and I've been working with Discover for about 2 on their OpenShift adoption. Sachin, do you want to introduce yourself?
Yeah, hi, my name is Sachin Chawda. I'm Principal System Architect at Discover Financial Services. With the Discover, I've been working with 3 years, and I just started with the OpenShift team a year ago and started working on the Kubernetes and OpenShift platform.
All right. All right, so as you are probably aware of, OpenShift provides many benefits for developers and application teams, such as application auto-scaling, self-scaling applications. It has an S2Y system to enable easy builds within the cluster. There's all kinds of benefits, all kinds of reasons to adopt OpenShift. But of course, anytime you move to a new platform, there's going to be some time that it takes to actually ramp up on that platform. It takes time to become proficient on a new platform. There's a lot of reasons. Here's 4 high-level reasons. One is new workflows, new ways of doing things in the platform, new tools to get there, such as the OC CLI, the Helm CLI, which we'll learn more about later. There's new lingo, right? What are containers? What is DevOps? So there's all kinds of new terms and phrases to learn there. And then new concepts, and that kind of goes hand in hand with the lingo, concepts around, or best practices around containers, around deploying applications in OpenShift, so on and so forth. There's many different ways to approach application development on OpenShift. You might have asked yourself one of these questions, or you might have asked yourself all of them, right? Which tools will we use? There's a lot of tools out there in the community. How do you know which tools are the right tools for you? And kind of going off of that, how will you actually build and deploy your application images? Once you kind of have a process in place manually, how are you going to automate that? How are you going to provide reusable components for other teams? There's a lot of different app teams in your organization. You don't want them all to have to reinvent the wheel. You want to provide something for them so that they can hit the ground running sooner. They can become productive on the platform as soon as possible. two more here. How do people know what they're doing is the recommended solution when they're new to the platform? How do they know what they're doing is actually the best practice? And what OpenShift resources do we need to configure, right? If you are familiar with OpenShift and Kubernetes, there's a lot of resources. There's deployment, services, routes. How do you know you're using the proper services or the proper resources for your use case? So as a member of a OpenShift operations team or as a member of a DevOps team, we feel that it's your job to provide a set of common tooling and processes for application teams. And by doing that, what you do is you decrease the amount of training and overhead that application teams feel to get acquainted with that environment. You establish a direct and trusted approach maintained by the platform team. When people have questions, they can come to you as the subject matter experts, as the maintainers of their tooling that they use to develop on the platform. Like I was saying, they have a centralized location for getting support. They have a set of reusable components, and so that goes back, team to team. You have a set of components that you can distribute throughout there. And then an out-of-the-box working solution. They don't have to develop this on their own. They can use what you've already provided, what you've already tested and vetted out to make them more productive. So our solution that we came up with at Discover is to build an enterprise Helm chart repository. So you can see a few different Helm charts here: image build, Node.js, so on. We'll get to each of these in detail in a little bit. First, I want to talk a little bit about Helm, give a little bit of a Helm 101 before we dive into the nitty-gritty technical details here. So a quick review of Helm. Helm is known as the Kubernetes package manager. It's named that because it's very similar to an operating system package manager. If I say yum install Ansible, I just expect Ansible to be installed on my computer. Helm kind of works in that same way with Kubernetes. And so quick little glance at Helm. I left a couple links there about the project. It just received, it just reached graduated status with the CNCF last year, which is very exciting. And they have a highly active development community, and there's some stats there that you can see. So Helm 101 here. Helm creates a wrapper called charts around OCP resources. And so what you can see here is a Helm chart wrapping around a deployment, a service, a config map, and a route. So 4 common resources that you might need to deploy as OpenShift application. And then a user, instead of having to go in and create each of these resources by hand, they can just run one command, Helm install, and it's actually going to go and create each of these resources for them. A Helm chart is written by a subject matter expert, by a member of your operations team or your DevOps team. And so this is what they would see. And the benefit that they have is that YAML definitions are dynamically generated. So you can see there in red, those are placeholders for parameters. So, the number of replicas that you want in your deployment, the user can specify that. The user can specify the image that they want in their container, the resources there. So an operator, a human operator would write this YAML, and then the user would receive the benefit by not having to write all of the YAML there in black. Just the red there would be replaced by their input. So kind of expanding on that, users configure their installation using values. So there's kind of an example values file there. So you can see, going back to what I was saying earlier, the number of replicas, the image, resources, so on. And to install that, they run one simple command, Helm install, and they give it a name. So my app, point it to the Helm chart that they're using. So our Spring Boot Helm chart, and then -- values, should be 2 dashes there. Values.yaml to refer to those parameters. And then there you go. It gives you those resources there without you having to actually have written the hundreds of lines of YAML that you would normally require to configure those. So at this point, I'm going to hand it over to Sachin. He's going to get more in detail with DFS Helm chart repository. I'll stop sharing, Sachin, and then you can take it away.
Thanks, Austin, for explaining about the Helm and the Kubernetes Package Manager. So at the DFS, Discover Financial Services, we have a Helm chart repository where we are maintaining the Helm charts. Now, this Helm chart has been maintained by the OpenShift platform team. The source code for the charts are located in the GitHub. We try to package those chart and archive into the Artifactory. We try to maintain the good versioning of all the changes with respect to the change logs, and then app dev team can pin to specific version of the chart so that it's not a breaking changes for that application. The Helm charts provides the common set of components for all the application teams, and it's opinionated towards the solution to prescribed by the enterprise platform team. So we started with building the image build chart for kind of building the application image, which translate into the OpenShift build config. Then we have a specific set of deployment chart for each set of technology, like a Node.js chart for the Node.js applications, Spring Boot chart for the Spring Boot application, and then there's a generic deployment chart. So this chart is kind of unopinionated towards any language or framework. And then there are a set of common templates or boilerplate codes. We are trying to abstract that in the library chart. So the way we have structured this is if application developer needs to work with the Helm CLI, they need to install this repository, Helm repository, using the Helm repo add command. Once they add the Helm chart repository into their local workstation, they can work with the specific Helm chart, and then they can issue the Helm install or update releases based on the specific Helm chart. Like in this example, it's a Spring Boot Helm chart, and then they can provide the set of values. Now, there's also a way in terms of the OpenShift UI, which we are going to explore it in the future. But this UI provides a nice way to configure the Helm chart, and then application team can utilize those Helm chart via the UI, OpenShift UI. So while running the application on the OpenShift, there are two high-level steps. One is a build and deploy. So we are targeting in terms of the specific Helm chart for this build and deploy process. So building the application is like building the application image and pushing it to the OpenShift registry. And for deployment, it's going to pull from the OpenShift registry and going to deploy on the OpenShift and create the set of resources on the OpenShift platform. The way it works, like app dev will be reviewing the image build chart. In our case, it's image build, which is building the image. So it's going to read the documentation, and then we are providing the samples for the app dev team. So they will be referring to those samples, trying to clone those values into their local repository. And then they're going to issue the Helm install command, and that's how it's going to start building the application image. Now there are a set of flags which they can enable so that the build starts automatically, or they can manually trigger the build. So once the build is done, next step will be creating the Artifactory image. It will be stored, and then now the next step is for deployment. Now, based on the technology the application is built on, they can use either Spring Boot, Node.js, or generic deployment Helm charts. So they'll review the chart documentation. We are providing the examples of the demos application so that they can refer those values files, and then they can issue the Helm install command with the specific technology related Helm chart, like in this example, Spring Boot, and deploy those application image to the OpenShift platform. So it also works great with the CI/CD pipeline. What I explained in the previous two steps is more of the manual way of using the Helm CLI in terms of for the local workstation. But if they have a Jenkins kind of a pipeline, then they can plug in these two stages. Like the one is the build stage, where they're going to use the image build chart to build the application image. and then it followed by the deploy stage where they're going to deploy the application to the OpenShift platform. Now, creating an enterprise Helm chart repository, there are a specific set of requirements. So the code base. So we are maintaining the Helm chart code base in the GitHub, and it follows a specific structure. So in our case, there are a series of Helm charts. So we are maintaining those in the GitHub repo along with the README and its pipeline. And then in terms of the storing the Helm chart, we are using the image registry. In this case, if one can use the Artifactory in Access in terms of the image registry for the along with the Helm chart repository. So there are high-level design consideration while building the Helm chart. Consider the user experience. Design the charts to require a few values input as possible from the user. So you can abstract some of the values from the user so that user can provide the minimal input in terms of values. You can abstract the service integration as well, like if they are trying to connect to the external service via proxy or database, you can abstract that in terms of the Helm values. And try to design the chart as flexible as possible so that user can provide its custom input as well in terms of the init container, sidecar container. And you have to make sure that you are versioning the charts properly so there are no breaking changes. If application is using specific version of the chart and you're upgrading it, you just make sure that your versions are maintained so that it doesn't break the application. Document each chart's intended use, so it's a clear in terms of usage. If it is a generic chart, make sure that you define the requirement for that. Simplify the internal reference such as container registry URLs, enterprise container image values wherever it's possible. And provide the examples, demos of the project so that community can learn faster and they can utilize those Helm charts. We can make the Helm chart development easier with the library chart. Like we can abstract the common code into library chart so that it can be used by the other charts. So in this example, we are trying to define the library chart, which is going to capture the boilerplate reusable code, and then we can use that library chart as an include in terms of the specific chart. So for example, if you're building a generic deployment chart, you can include that library chart. And also if you are building the Spring Boot or Node.js, you can include this library chart reference to that. And for the, since we are building the Helm chart, we run through the CI/CD process for the Helm chart as well. Like there's a CI pipeline, which is testing, packaging, and releasing the Helm chart based on a specific version of changes. So we are using the CT tool, which is going to chart testing tool, which is the series of steps going to follow. CT init is going to list all the update chart. Then CT install is going to install the chart. Helm package is to package the chart, and then we can push it to the Artifactory or repository using the call command. Thank you, and let us know if any questions.
I see no questions.
I see no questions. I think that's amazing because, whoops, there we go. We're going to stop that there. So one of the things that's really interesting to me is because there's operators and Helm and all of the other.
Hello, thank you for attending our talk.
Now I'm just going to pause that there. I love this automated system we have here. But I really love the way that you've taken this use of the Helm enterprise repository to the next level. And I'm wondering, Sachin, a little bit what the impact has been on your development team going forward to be able to leverage all of that.
Sure, thanks, Dan. So initially, since it's a new tool, new technology, there's a learning curve for them.
But since we provided the examples demo, it was really helpful for the app dev community to refer the demo, try it out, and we are providing these set of guides in terms of this step by step. So they were kind of using those steps, trying to utilize the Helm charts which we have built, and it was easier for app dev team in terms of build and deployment. So they are focusing more on the business aspect of what I had to do a logic in terms of the code and all. But in terms of build and deployment was very well simplified. And since we are releasing like the Helm chart like updates frequently, we are just notifying via the release notes, so they are aware of the upcoming changes. And if they want to utilize those features, they can refer the changelog or README file and apply those updates to their application.
And so, Austin, any feedback from your point of view? I know you're embedded at Discover, and how's that been going for you? And where are you taking them next?
Yeah, it's been going really great, and I think to add on to your previous question, what I really like about this setup is that think of all the different Kubernetes resources, different OpenShift resources that there are, and how much configuration actually goes into creating a deployment, a config map, a service, a route, this, that. There's a lot of different config options in there. And with the Helm chart, a user can simply provide maybe 10 lines of YAML, to create what ends up being thousands of lines of config down the road. So I think that is a huge part of the value that we're providing, and I think that's what is allowing teams to jump onto the platform and actually start being productive so quickly, from day one. And like Sachin was saying, we do provide demos. We're always available to provide support for those teams. So yeah, I've been really excited about the work that we've been doing. I think that Discover and their application teams are also very excited. As far as what's next, we're gonna just kind of keep steering this whole thing forward. They've got a lot of apps that they're looking to onboard, and we plan to just use the Helm chart repository to kind of get them there. So.
All right.
Yeah.
Well, thank you guys so much for joining us today. We're really looking forward to hearing even more. We've heard about how you're getting your apps on there, but maybe the next time you come, we can talk about what the workloads are on at Discover Financial, what you're actually, some of the implementation of some of these applications. I think there's some really interesting things that you guys are doing on top of OpenShift too. So it's wonderful to hear how it's getting done. Now the next stage is to see what exciting things you actually deploy, and if we can get you to talk about those. I know you had to jump through a number of hoops to be allowed to talk, and we totally appreciate you for taking the time and sharing your story. So Sachin and Austin, thanks for getting up in the morning wherever you were, and we'll take you to our next talk now, which is from another longtime OpenShift group. Amadeus is going to come on now and talk about end-to-end OCP4 cluster deployment automation in their IT context. And so I'm going to stage that now. Bear with me while I shift over to that session. And thanks again, Sachin and Austin, and we'll get the other speakers popped in here shortly. So we're going a little bit behind time, so bear with me, everybody, but we're doing it. And again, great talks from end users coming up. So hang tight, folks.
Thanks a lot, everybody.
Cheers. So hello, thank you for attending our talk, End-to-End OpenShift 4 Clusters Deployment Automation in Amadeus IT Context. So my name is Maria Alejandra Manueli. I'm an OpenShift Red Hat consultant working in the Ironman Amadeus project with my colleagues Vincent Bronikowski and Thibaut Castan. I will let them introduce themselves.
Hello, so I'm Vincent Bronikovsky, an OpenShift Red Hat consultant, and I've worked with Maria and Thibault on this project.
Hello, my name is Thibault Castin. I am a senior SRE working at Amadeus. I'm specialized in cloud platform migration and operation, and I have been working with OpenShift and Kubernetes since 2015. I've been working closely with the Red Hat team all along that project. So before digging into the project itself, let's start by introducing Amadeus in a few words, for those who don't know what Amadeus is doing. So Amadeus is a technology company dedicated to the global travel industry. We're present in almost 200 countries with a worldwide team of more than 19,000 people. Our solutions help improve the business performance of travel agencies, corporations, airlines, airports, hotels, and more. So why is this project? Let's go back a few years ago to understand where Amadeus comes from with its cloud journey. So we started our cloud journey in 2014, even before the very first version of OpenShift 3. At the same moment, we also started our partnership with Red Hat, working closely with them on that topic. In the next few years, we at Amadeus gained quite a solid maturity in the use of OpenShift, deploying and operating dozens of clusters, mostly in our private cloud at first. Those private deployments are part of an internal project called Ironman. Ironman because its purpose is to provide a kind of a super IaaS and PaaS on-premise and for the long run. Those deployments are currently running on two Red Hat products. So OpenShift 3, we're currently on 3.11, and OpenStack. Then, in parallel, we also started to extend our capacity in the public cloud, so both on Google and Amazon. Then, since mid-2019, we started deploying OpenShift 4 in the public cloud, so mostly in Azure. And we're quite impressed to see how the installation, the upgrade, and the overall management of the platform has been transformed, simplifying our operation model for both day one, but also for day two. As you all know, the major event of 2019 is a COVID-19 crisis. And Amadeus being in the travel industry business, we have been impacted. So we could not grow our private cloud as intended, which became quite a blocker for Amadeus migration to the cloud, as there was still the need to further cloudify our operation model and applications. So in 2020, the low use of our classic infrastructure brought the opportunity of potential repurpose of several hundreds of servers to create a new IaaS cloud. And due to the usage of older hardware, this stack has been called Ironman Lite. And the purpose of this Ironman Lite project was to leverage the existing unused hardware and provide new cloud platforms with minimal cost and an excellent operational model thanks to OpenShift 4, and this to continue Amadeus migration to the cloud. So let's talk about Amadeus technical requirements for this project. So in Amadeus, we now have quite some experience deploying OpenShift 4 in the public cloud, mainly on Azure. But deploying it on-premise was a completely different challenge. And that's why we requested the expertise of Red Hat to help us on this task, as the core of this project was around two Red Hat products. OpenShift 4, so it was 4.6 at the time of the project, and OpenStack 16. So we had some precise requirements. First, we wanted a deployment model and operation of our private cloud as close as possible from the public one on Azure. And this to have a single way for SRE teams to manage our clusters. Second point, for our deployment on-premise, we have no direct internet access. So we needed a fully disconnected installation mode, where all the artifacts are fetched from internal repositories. We also wanted to use an API installation. So API stands for Installer Provision Infrastructure. And this to have the full cluster infrastructure provisioning self-managed by the OpenShift operators, and thanks to machine and machine set OpenShift resources. This was freeing us from the burden of managing ourselves the infrastructure and enabling easily great feature like cluster autoscaling. Then, fourth point, we wanted to use Calico as a SDN. As we use it a lot to enforce proper network security in Amadeus, we wanted to leverage a Calico feature like global network set to represent external CIDR block, or also global network policies. This to enforce some rules at a global cluster level. And those features do not exist with other CNIs. Finally, the idea of this project was to be able to create a full cluster with like a single command consuming a single config file and input. And this reusing some automation already built internally by Amadeus to deploy some cluster on Azure. So we don't have to struggle to recreate clusters and have a kind of a cluster as a service model. Okay, I will now let Vincent explain you more in detail about the project and the automation that has been built based on those requirements from Amadeus.
Thanks, Thibault. So the main thing we want to share with you in this talk is the experience of intercollaboration with a client and the Red Hat in a consulting project. So we started this project with a week of Navigate workshop. The Red Hat Navigate is a tried and test framework that helps our customers identify obstacles and align their business goals to deliver successful solutions. So the Navigate framework was delivered through a series of workshops, which covered a set of considerations for OpenShift. And each day we had different workshops that were talking about different subjects. So the project was delivered by the Red Hat as the principal leader with a collaboration of Amadeus. And as a team, Red Hat Consulting worked as an autonomous team within Amadeus, and the delivery has worked very well given the maturity of Amadeus in the OpenShift adoption journey. So I will talk a little bit to you about the implementation and delivery of the platform that Amadeus required. So based on the prerequisite that Thibault Castin told us, so we deployed on-premises cluster, which were on 3 ACID, so to prevent crashes if some server went down. It was the same thing for all the storage, which were using Cinder in different ACID, so everything was well dispatched on the infrastructure. And as a prerequisite, everything is being deployed with the IPI fashion, so you don't have to provision machines manually when scaling up the clusters. I will now talk a little bit about the big challenges that we had during the implementation of this project. And the first one was the Calico integration. So it was a big challenge because basically the use case of having Calico as an SDN on OpenShift on OpenStack as basically no documentation. So we had to do a lot of work and researches to understand how this component could be working on this specific integration. We had to do a lot of back and forth and testing in order to understand how Calico worked and how to make it viable with the needs of Amadeus. And in addition to that, after having Calico well configured, we had to configure and understand the Tiger operator, which was the component that basically deploys it automatically when creating clusters. So in short terms, the thing that we had to do a lot was diving into the code of this component to understand what's happening to make it work and make Amadeus happy about the Calico SDN. The next thing that we had as a challenge is having an OpenStack on-premise versus cloud provider solution. So since Amadeus wanted to have an excellent operational model, it was kind of complex to start from simple deployment using on-premise OpenStack and iterate through everything and all the prerequisites that OpenStack can have. So starting from the storage, from network configuration, etc., and how to deploy, for example, multi-AZ cluster. So this has kind of complicated to have an on-premise environment that was working as well as a cloud provider. And for example, even some really specific features weren't working as intended, and we had to do exchange with the engineering teams to have everything fixed for the next releases of OpenShift on OpenStack. The last thing, as a challenge that we have seen as a big challenge, was being reactive with all the Amadeus assets and needs. So the integration were quite complicated, and with everything of that, we had then to integrate with all the tools that Amadeus already possesses. So since they are really mature, for example, they have a tool that is called the Amadeus Wrapper that helps them to integrate manifest when creating clusters. So all the work we had done previously in cluster, we had to then integrate everything with in the Amadeus manner with all the tools. And since Amadeus is really mature, when they had some questions or some needs, because this project was quite new, we had to come fast with tailored solutions that were quick and elegant, so they can be happy and to make everything work properly. So I will let Maria talk a little bit now about the automation tool and technically speaking, and how it has been implemented on the Amadeus side. Thanks.
Thank you very much, Vincent. So while performing Navigate workshops, we do this exercise where we ask the client to identify business priorities. We get them to vote on their top 3, and then we go deep into the explanation of why these were chosen. So for Amadeus, the main business priority identified was operational excellence and then efficiency. So at the heart of this conversation, there was the topic of automation. We can see on the screen an extract of this exercise where automation was brought up several times. You could definitely see that this was at the organization's mind. Every talk of processes involved the question, can this be automated? This wasn't something new for Amadeus either. They had already advanced quite a lot on the automation topic. As Vincent and Tiva mentioned, there was the existence of what they called a wrapper, which leveraged the OpenShift installer to add manifests like, for example, the Calico manifest or day 2 operations during the install, as well as an automation tool based on Terraform to automate the installation of OpenShift clusters in Azure. So the easy adoption of Amadeus, the easy adoption of automation by Amadeus made it so we could work side by side to create a process that allowed us to spun up clusters on one click. So automation became very quickly one of the top priorities of this project. So the OpenShift installation was automated from start to end. So how did we do this? Let's dig a little deeper on the technical side. So the automation tool was based on 2 technologies, heat orchestration and Terraform. So first, let's talk about e-templates. So as mentioned, a yes was deployed with OpenStack, and then OpenShift was installed on top of OpenStack to create a private cloud solution with infrastructure as a service and platform as a service capabilities. So e-templates describe the OpenStack infrastructure for a cloud application in a text file, such as the one you see on the slide. This text file is leveraged to create a stack of infrastructure resources, such as networks, subnet, the Bastion server, and others. The high integration of e-template as an orchestration technology for OpenStack made it an obvious choice as a technology to use. This allowed us to deploy all the OpenStack prerequisites to install OpenShift on top of OpenStack. So now that we know the Bastion server was automatically deployed by e-templates, you may be wondering, how did we to actually configure the Bastion server? So for this, we used Cloud Init. So Cloud Init is an industry standard that identifies the cloud is running on during boot, reads any provided metadata, and configures the system accordingly. So this allowed us to configure the Bastion server during boot time automatically. So the moment the Bastion server spun up, repositories are configured. As Thibault mentioned, it's a disconnected install, so we needed to configure the repositories, the internal repositories of Amadeus. Then packages are installed. The clients and the OpenShift installer, clients such as the OC client, OpenShift client, and Swift client are installed. Then the installation objects, such as configuration files, are downloaded, in this case from a Swift container. And finally, with the run command resource, Cloud Init launches the cluster installation. So where does Terraform come in? So Terraform is the glue that brings all of this together. So to give it a little context, Terraform is an open source infrastructure as code tool that includes an OpenStack provider, which allows us to create OpenStack resources, such as, for example, leveraging e-templates to create an orchestration stack. The Terraform also includes an Azure provider, which is why it was used as a tool to create the automation for Azure clusters. So how is Terraform the glue? Well, we have three main things that we needed from this automation tool. So we needed to deploy the templates in a sequence. So for example, we need to deploy first the template with the project to install OpenShift, and then everything else that's deployed on the project. Then we needed to create installation objects and installation configuration files from different templates, and we needed the ability to variabilize these files and these objects. So all of this was allowed by Terraform. So at the end, the automation looks something like the diagram you see on the screen. So if we go a little deeper on the diagram, the Terraform creates a orchestration stack, which is the one you see right now as stack tenant on the diagram, that deploys the project where OpenShift will be installed, sets up the user role assignments, configures the code test for this project. Then Terraform creates the floating IPs for the ingress and for the API, as well as a Swift container that will store the installation objects. The installation objects are created from a Terraform template, and the floating IPs, cluster parameters, project names are added accordingly. And then finally, an orchestration stack, which is the one you see as stack server, is created, which deploys the OpenStack prerequisites, the Bastion server, and finally launches the OpenShift cluster. So as you can see here, the stack deploys the networks, subnet, router, the floating IP for the server, the ports, and as well the cloud config resources that will configure the Bastion server. So this automation tool allowed Amadeus to deploy clusters in a repeatable way and on demand, serving as cluster as a service. So this already made this project really, really interesting. But in my opinion, there's something even less tangible than technology that made this project interesting, and is the fact that this part of the project was looking to standardize processes within Amadeus. So this required to create a synergy between Red Hat and Amadeus. So while creating this tool, there was always the conversation, where would this tool be compatible with what is already done, or will be compatible with the existing infrastructure and workflows. So this goes along really well with the Red Hat principle of putting the client first and adapting what you do to your client's need. So now we'll go on to specify the benefits and wins of this project.
Okay, so the first point, and I think it was maybe the main goal of this project, is that we are now able in Amadeus to provision a production-ready cluster using OpenShift 4 in our private cloud. And this allows us to move traffic from our legacy infrastructure and support thousands of transactions per second on our new on-premise cloud platforms. The second point, and it is also a consequence of the first item, this project enables Amadeus to continue its cloud migration. So first from the legacy infrastructure, but also from the existing OpenShift 3 platforms. And this leveraging all the great features of OpenShift 4 for the on-premise deployment.
So one of the main benefits of this project as well is the automation of the OpenShift cluster, which allows to create clusters in a repeatable way using one single configuration file and on demand.
Last but not least, the maintenance of a good relationship with a client, which is Amadeus, which is a faithful and long-time client, and it's cool, especially during these challenging times.
Thank you, everybody, for attending our talk. And I want to give a special thank you to one of our colleagues, Thibaut Desmarais, that worked with us along this project, and the project wouldn't have been possible without him. Now we'll be answering questions on the chat.
Well, hello, everybody, and welcome back, and thank you all, and especially Thibaut from Amadeus, for joining us here today. Much appreciated. It's always a pleasure to have Amadeus sharing what they're doing here. And there've been a number of questions that have been coming in, and people are asking in the chat through Q&A and stuff. Shingo was asking, do these services and Amadeus have infrastructure stress tests like chaos engineering before release? What are suitable tools for stress testing and a private cloud? Would one of you like to try and talk to that one?
Yes. So can you hear me?
Yes, definitely.
Yes. Okay, perfect. So yes, definitely we are doing some tests. I wouldn't say that the testing are industrialized yet. We are mainly testing the storage part. We know that the storage can have a lot of impact, especially when etcd is stored. So there are tools like FIOs that are used to test the performance of the storage. Then apart from that, of course, there are more, I will say, functional testing for the application itself to test the response of the application itself, because it's important to test the infrastructure, but also the application are running on it. So these are more functional and done by dedicated team in Amadeus.
Cool. And Vishy is asking about how long have you been running this on-prem cluster, and how much painful is it to upgrade the cluster, particularly say for Calico when the implementation had challenges? Is there some feedback, Vincent, Maria, or Thibault, that you have on that?
Maria, you want to answer? You want to? I saw you unmuted.
Yeah, well, so the installation of this project was done last year in November. So it's been going since November. And for the upgrade with Calico, it has been as with any other SDN. So it really hasn't been a problem once it's installed. It's just during the installation, we had to verify the integration of Calico with OpenStack, and then the several requirements that Calico had to be able to perform the installation. But once installed, the upgrade has been done without a problem.
All right.
It's not automated though.
It's the key piece of it. I'm not seeing any other questions coming in from the chat or in the Q&A. I think you've answered them all. So if you don't mind hanging out around in the chat and seeing if things come up, we are always, as always, at gatherings running a little bit behind. So I'm going to thank you, Thibault and Vincent and Maria, for taking the time and joining us here. Luckily, I think it's all in your time zones. So it's probably not, I can see light coming in the window from Thibault's thing. So that's pretty good, because here it's still pitch black, and we're on the West Coast. So I'm totally appreciative of you taking the time today. And I'm looking forward to hearing what comes up next in your roadmaps too. So stay tuned. People, they'll be in the chat and you can ask questions there if you have them. And now we're going to queue up a talk from Saulius Prismantis from Six Digital Exchange with a couple of Red Hatters, Radu Domino and Marcel Hari. And so we'll start that one off now. And thank you all for joining us, and stay tuned. And here we go. Trying once again to start the broadcast correctly. I'm going to add these people and hi. And it just takes a minute to get everybody set up here. So hang on. Goodbye, Thibault. And Vincent, yeah, it's letting me remove you. There we go. We've got 2 out of 3 going. That's not bad. So here, let me share the screen and kick off the video and see if I can do this. Share the audio, cost reduction. There we go. And All right, we're having just a little technical difficulty again, so hang on. We're going to start again and see if we can do this right.
This is 6 groups. All right, welcome to our talk on cost and resource management, management on CI/CD infrastructure by using OpenShift. So a few words about ourselves. My name is Saulos Prosmantas. I work as a SRE at SDX.
My name is Marcel Harry. I work as a cloud architect in the services team at Red Hat. I'm mainly focused on customers within the Alps region and there on infrastructure and OpenShift 4 topic.
Hello, my name is Radu Domno. I work as a cloud consultant in the services team as Marcel in the Alps region. I'm focusing mostly on OpenShift and cloud native ecosystem.
Okay, thank you guys. So we all work at SDX at the moment. This is a 6-group company providing financial market infrastructure services in Switzerland. There are over 200 employees, and we build DLT-based solutions. We're part of blockchain network. Primarily, we use R3 Corda, but as you can see, we also partner with Hyperledger and Enterprise Ethereum Alliance. So we build a number of products where we provide trading infrastructure.
notes, I will give the word to Solios to do the wrap-up.
Thank you, Radu. So just to finish, a few takeaways. So autoscaling, as you can see, it works, but it requires proper configuration and some tuning to be done. GitLab turns out to be a very flexible framework, which allow us to configure building software for developers. And we found that container-based hybrid infrastructure suits very well for these kind of workloads. So thanks a lot. Thanks for tuning in, and see you in the next ones.
So hello, everybody, and welcome back. And as everyone can probably figure out, we're running about 20 minutes behind schedule, which is pretty normal for a gathering. But I really wanted to take a moment and thank Salas and Marcel and Radu for joining us today. There have been some questions in the chat. I'm looking to check in the Q&A to see if anybody's come up with anything. Vishy is asking, why can you just taint one node exclusively for this purpose instead of this priority scheduling? I'll approve that one and release it out to the wild. I'm wondering if that's something Marcel or Radu could answer.
Radu, you want to take it over?
Oops, Radu, you've got yourself on mute. Let me unmute you. Unmute for everyone. There you go. Well, keep trying. Hit the unmute button.
Okay, I clicked on by mistake. Sorry. Okay, so the question was about why priority.
Yeah, maybe, or so basically by tainting a node, you would not allowing workload to be provisioned, and then it would not be part of the standard Kubernetes scheduler selection. Thus, it would not count into the autoscaler decision of whether it needs to add new nodes or not within the machine set. And so you need a way where there is workload that cannot be provisioned, and then when a new node gets in, it needs to get provisioned. So also, if you have a taint, you would need to remove that taint at the moment when all the other nodes are full, and this is not something that the cluster autoscheduler works on. It basically looks at is the kube scheduler able to fulfill all the requested resources, and if not, I'm adding new machines to the machine set, or I'm removing ones if there are more than enough resources available.
I think that probably answers his question. I'm looking to see if he's asking again any follow-up on that, Vishy, in the chat. No, I thought maybe Salas, if you had a few words, someone's asking another question in chat. Here we go. How do you handle secrets for jobs?
That's a question for Solius.
And Solius,
you need to unmute.
Unmute as well. So there you go. See if I can unmute for you. And you're still muted. All right. I think you have to click in, Salas, and unmute yourself. Maybe not. Maybe we'll have to pause and answer that question in the actual typing of the chat. Thank you very much for the presentation. You guys, if you can hang out in the chat and answer any further questions, we'll queue up our next group of speakers here. And thank you very much for taking the time and joining us today and answering the questions. And thanks everybody for your patience with the Hop-In platform. We are running about 20 minutes behind. at least. And we're next up, we have the Bank of Oklahoma financials is going to talk about modernizing a banking application using the IBM Cloud Pak for automation on OpenShift. So if you're up for that, we're going to stage that now and get that running. So take care, Salas, Marcel, and Radu. Thanks, and we'll talk to you all soon.
Thank you. Bye.
Bye. Thank you.
We're going to try that again.
Hello all, I'm Faisal Kader. I'm a specialist SE in the sales team that manages this account. I specialize in OpenShift and related Red Hat technologies. I'm Kubernetes and OpenShift certified. I closely work with Lance Preston, the infrastructure architect from BOKF, in setting up the different OpenShift clusters until production environment. On these clusters, IBM Cloud Pak for automation with its FileNet product is hosted. I closely work with him, helping him navigate through all the challenges with the infrastructure and provided the necessary enablement to help him complete this effort. Working together, we managed to tackle all the roadblocks and have led to this great success story for the bank and Red Hat. I'll hand it over to Lance to share his experience.
Hello, my name is Lance Preston. I am an infrastructure architect with BOK Financial Corporation, which is headquartered in Tulsa, Oklahoma. I'm here today to talk about banking app modernization via the IBM Cloud Pak for automation on the OpenShift container platform. So we started our app modernization journey basically in the fall of 2019 when we began planning to replace our legacy FileNet platform. And I believe I'm sharing that information on the screen now. So I'll talk about what our legacy platform looked like here in just a minute. But basically, at that time, what we needed was a solution that was going to be supported for the foreseeable future, as well as being more easily scalable and that could support the needs of our business, which included adding some additional products within that content management platform provided by IBM. So in the fall of 2019 is when we really began talking seriously with IBM and Red Hat about building out a new environment for our content management platform. And it was at that time that they suggested that instead of using the, just upgrading the components in our legacy platform, that we look at going with containers and Kubernetes, and specifically the OpenShift platform. So I'll talk a little bit about what our legacy environment looked like. We basically had the IBM FileNet P8 platform, which was version 5.2. We were running the IBM Content Navigator kind of separately as a front end to FileNet for our users to access the documents and the content within FileNet. This was all running within the WebSphere Application Server Network Deployment Edition, version 7.0 and 8.5. We had a combination of both. And these were connecting to an Oracle database that was clustered within Power HA. All of these were running on our IBM Power 8 hardware, running the AIX 7.2 operating system. So I will kind of show you what that looked like from a visual perspective here. I'm not sure if I can get that any larger. There we go. So basically, so all of these are AIX LPARs in our IBM Power Platform, right? Our Oracle database that these LPARs, which are the content platform engine, which is where the majority of the content is served up, right? And it is stored on our network attached storage platform on site. This is all on premise, by the way. And then the content navigator application, which will load balance and would front end the content platform engine applications. We also have kind of a legacy piece that's called the application engine, which is used by a couple of other lines of business. So all of these are, so the AE servers, the application engines, were running WebSphere Network Deployment Edition version 7.0. The CPE servers were WebSphere ND 8.5, and the Content Navigator was also WebSphere ND 8.5. These are all separate AIX LPARs in our on-prem Power 8 environment. So growing this and expanding this, right, is a little bit of a chore. We can obviously add additional resources to each of these servers as needed, but if we need to stand up another server, right, to scale out the environment, that's obviously a lot of work. We have to build another AIX LPAR. We have to install WebSphere. We have to join that into the existing cluster and get the applications deployed to that. So the solution that we came up with IBM and Red Hat was to deploy what we consider our modern environment, right, which is the basically the IBM Cloud Pak for Automation, right? So we are currently at release 20.0.3 FixPak 2 for the Cloud Pak for Automation platform. That is running in an Red Hat OpenShift 4.6 environment on our on-prem VMware vSphere 7 platform. Right, so all of our Red Hat OpenShift nodes are just essentially Red Hat Linux Core OS VMs running in our on-prem VMware platform. We have the IBM Cloud Pak for Automation deployed to that environment. We are still running the content platform engine, which is the IBM FileNet P8 product, but it is a later version, right? It's version 5.5. It also is still front-ended by the IBM Content Navigator, which they refer to as the BAN application within the Cloud Pak for Automation. But these are now running WebSphere Liberty within the containers within this application. So here's kind of a visual of what that looks like. Well, and all of these environments are still connecting to an Oracle database on-prem that still resides in our AIX platform in the IBM Power 8 hardware. So this now looks like this, essentially. So we have our on-prem VMware cluster, which is a couple of dozen servers at least in our production environment, and those VMs are our Red Hat Core OS nodes. We've got the 3 master nodes. We currently have 4 worker nodes that are all running Red Hat 4.6.16, I believe is the version we're currently at. These are all on on-prem VM data stores in our VMware environment on our enterprise SAN. We have a management node that is used to deploy the applications, right? That's where we run the OC or the kube control, command line interface for the cluster. We do also use the OpenShift GUI for management of that cluster from time to time, but a lot of the tasks that we do command line through this management node. This all is still front-ended through our on-premise load balancer appliances. And then all of the Cloud Pak for Automation applications, those containers and pods, right, they reside within this cluster, right? They run on various nodes within this cluster. And then the persistent storage for those applications, as well as our content within the FileNet platform, is still on our NAS platform, right, our network attached storage. And then those environments still connect to our on-prem Oracle database instances, which are clustered together in a Power HA environment in running on our AIX 7.2 platform. And again, this is all on-premise. So it took us quite a while to actually get to this point, to get this environment stood up. There was a pretty steep learning curve from our perspective to be able to get this environment in place. But we did receive a lot of help from both Red Hat and from IBM. Red Hat specifically on getting the OpenShift cluster stood up and working, and any problems we had with that. And then, of course, IBM with the Cloud Pak for Automation packages that we got deployed. We struggled with it a little bit, but we were able to overcome any issues or difficulties that we had with assistance from both of Red Hat and IBM, and have a test dev cluster stood up, as well as a production and a disaster recovery cluster stood up. This image is depicting our production cluster. But now that we have this in place, and now that it's stood up, right, scaling out these applications is much easier, right? We can just scale up the deployment and immediately have additional instances of the application that are serving our customers. As well as upgrading the cluster itself is relatively straightforward. It's a very simple process. And then upgrading the Cloud Pak for Automation packages themselves, that bundle, it's a much easier process than the legacy platform, right? When we used to have to do an upgrade for FileNet or for Content Navigator, right, that was pretty much an entire weekend, right? Several employees working together for the majority of a weekend, which is when we could take the downtime for the application to have it offline for hours or half a day at a time in order to do the upgrades and test it out and make sure everything was working before we went back into production, Monday morning. Now that upgrade process, right, can occur basically within a couple of hours at most, generally less than an hour. And it can be done with the applications online, right? We just deploy the new application, apply a new configuration file, right, a YAML file, and the upgrade kind of happens by itself in the background, with the old version of the application still available until the new application is fully deployed and those containers come online, and it's just like flipping a switch. And then backing it back out is just as simple. Right? So much easier in the new environment than the legacy platform. I can't really speak to the performance of the new environment yet. While we do have this production environment built out, we are still in the process of loading content and data to the FileNet platform to serve to our customers. So they currently are still using the legacy platform, but as we migrate that content to the new platform and make that available, more users will eventually cut over to this new platform, and we will have a much better idea at that point of, load and the performance that the new environment can provide. We're optimistic. We don't have any reason to believe that the new environment won't perform as well as, if not better than the legacy platform, but we have yet to have any concrete data on that. That's basically what I wanted to present to you. So thank you for your time. I appreciate you paying attention. I hope you find this information useful. Have a great day. Thank you.
Thank you, Lance, for sharing this wonderful insight on this topic. And thank you all for listening. Lance, myself, and my associates are available to take any questions in the chat.
All right, then. Lance, thanks again. I'm really thrilled. It's really nice to see someone using the IBM Cloud Paks for apps in this manner and to help migrate some of this legacy efforts here. Do you have any words to add now that you've seen this? I've seen a couple of questions in the chat, but I think they've all been answered, Faisal. Thanks again for this talk. But is any final words? Faisal, can you unmute yourself? I can't see your video, but I know you.
Yeah. So this has been a tremendous experience so far. Is there anything, Lance, that could have made it a little easier for you during this journey? Do you think of anything top of your mind right now?
Yeah. So specifically, I think it would have been much more beneficial to take some of the OpenShift training classes ahead of time, right, before the project had started, so that we had a little bit more experience and knowledge of the platform prior to, in going down that road. We pretty much learned it from scratch and kind of on the job experience as we went along. So I think having a couple of training classes under our belt prior to starting the process definitely would have been helpful. I have since we've started the journey, I have taken a couple of training classes and they've all been very, very useful and very beneficial. So I think having that knowledge, a year ago definitely would have been helpful before we started the project.
All right. Well, that's a good plug for some of the OpenShift training. There's lots of opportunities with online stuff with tryopenshift.com and learnopenshift.com, as well as all of the great classes and courses that are available. So thanks for that tip, Lance. And Faisal, thank you for organizing today's talk. Really appreciate it. If you can stay on in the chat, we'll queue up the next final talk from Anthem on their Health OS system. And I know everybody, thanks for bearing with us. We're barreling through this content today to get to the end of our journey. And so you can all continue on yours with KubeCon this week. So the next talk is coming from a group that have been doing some really interesting work with Spiffy and other projects. Talk is called Health OS, Enabling Standards-Based Healthcare Interoperability with Cloud Native and Zero Trust. That's a lot of words, but I'm going to queue up that talk now. And thank you guys for joining us and bring in the next group of speakers. So thanks again, and we'll look forward to seeing you at the rest of KubeCon today.
Hi, my name is Bobby Samuel, and I've got Frederick Kautz here with me. And we're going to talk to you today about Health OS and enabling standards-based healthcare interoperability using cloud native and zero trust. So first of all, I'm Bobby. I work at Anthem. I lead up the Health OS development as well as Precision Insights. Frederick, would you like to introduce yourself?
Hello, I'm Frederick Kautz. I am a director of software engineering at ShareCare, and I collaborate with Bobby and Anthem on zero trust and a variety of architectures and systems.
So the way we're going to walk through this today is we'll start with the business case or the business challenge, and then we'll move into the technology, and then be here to answer any questions. So first of all, what's the challenge? What's the point of all this? So Health OS is something that we've created internally here within Anthem, and payers are seen as the middleman pain point across the ecosystem and causing abrasion across various user segments, whether it's provider, member, or even to other payers. But we also sit in a position where we have the richest longitudinal view of data, and that's whole health data about the person. So Health OS helps us operationalize our health data to drive improved outcomes and reduce costs, and overall, increases efficiency. So we'll talk to you about how we do that. But at the foundation of it all, Health OS is a platform. It's a hub whose primary emphasis is interoperability, and then driving world-class experiences, and uses machine learning and AI to drive insights and also actions. So just to talk about the business architecture and how the pieces fit together, at the bottom we've got the data layer, and that data layer, it focuses on integrations with EHRs. It's got payer and clinical data, and then our data about members or our constituents is based on FHIR, or the FHIR standard. On top of that layer, and this is where we'll get into cloud native and zero trust, but in that space, in the security layer, in our platform layer, we've got a number of things that are running and happening. So insights and action apps live here, and are created here. We've got tool sets or IDEs, and tool sets to rapidly build, validate, and or deploy health apps. And then this is where we'll talk about where we're implementing zero trust to do workload identity management. And then on top of that, we've got interaction layer. So the cool thing about Health OS is that, or one of the many things about Health OS, is that whether it's a UI UX that Health OS manages, or a UI UX that someone else manages, whether it's another EHR or a homegrown app that we have, those all plug into and have the benefit of connecting back into all of these health apps and back into the place where we've got the rich data stores. So this is the ecosystem that we've been putting together with our client client application endpoints to connect, as well as SDK, our SDKs to build and rapidly deploy apps. So in our ecosystem, what are we trying to do this for? And at Anthem, we have a number of partners we work with. We have a number of partners that we connect with in various lines of business. But the big problem is they're not connected. Anthem's connected to them, but they're not connected to each other. And what this allows us to do is to connect all the apps to each other. So Health OS allows us to connect to Anthem's data ocean. It allows health apps, insights, and actions to run and connect all these different apps. So we bring our digital ecosystem together, and we bring our EMR systems together that we connect with, as well as internal systems that exist within Anthem. All of these things working together, focused on better outcome for the member. And so let me zoom back out into what's our ecosystem and where zero trust kind of fits in. So we've put Health OS in the center. Once again, action apps and insight apps. So an example of an insight app would be what benefits are covered for Bobby, or does Bobby have this in his formulary, this particular drug in his formulary or treatment in his formulary. An action could be scheduling an appointment. It could be one-click prescriptions, or painless prior auth, one-click prior authorizations. And so those things run together, and then using zero trust connections, we connect to various clients like the desktop, or it could be, and I'm going counterclockwise right now, but like the desktop, it could be on AI ML tooling that we've got running that we can make insights available, third-party health solutions, and then even to clients like third-party clients like Telehealth OS, which telehealth has seen a huge rise in popularity and usage due to the pandemic, and then EMR apps or apps that do payment acceleration, as well as just traditional EMR platforms like in large hospital systems, Epic, Cerner, Athena Health, and all of these connected together, working together, once again, focused on our members' health and improving the health of humanity. And so what we'll do is we'll dive a bit more into how we're putting all of these things together on a cloud-native, zero-trust foundation to deploy this ecosystem. So Frederick, let me turn it to you.
Thank you, Bobby. So before we jump into zero trust, let's talk a little bit about some security basics. Very often when you speak with a security or information security person, you'll often hear about the CIA triad. We actually look at 4 things now, but the first 3 in the CIA is what traditionally people would look at. Those 3 are confidentiality. Is the information protected against unauthorized viewing or access? We look at integrity. Has the information been modified in a way that was unauthorized? How do we protect it from being modified? We also look at availability. Is the information available when you need it to be? And there's a 4th thing that has been added in more recent times called non-repudiation, which is how can you ensure that a entity that has performed a transaction cannot back out of that transaction? And there's multiple reasons for this, which could include at the business layer, how do you prevent fraud? How do you ensure that you can observe the system and know that that's what the state was likely to be? It could also be based upon trying to make sure that that when you're looking at security systems, that you know exactly who you're connecting with and that it hasn't been swapped out with someone else. So in general, there's now 4 main categories that people tend to look at. There's a couple others that people will bring in as well, but these are the main 4 that you tend to see. So using this particular framework, we then take a look at what are the business requirements? What is it that we're trying to protect? What has changed? So when we look at the zero trust space and why it's important, one of the things that we want to look at is what are the previous assumptions that we've made, and what is the reality that we're seeing today? What has changed? And the differences between that assumption and reality can be seen in the form of cyber attacks, where people will perform data breaches, will run ransomware, denial of service attacks, forging identities, or so on. And the policies that we tend to apply in from a regulatory or policy perspective may also end up ossifying some of those assumptions, end up entrenching those assumptions in such a way that they can be difficult to respond to. So zero trust is about realizing that we have these gaps and then building up a new framework that is more flexible in order to allow for response to these type of conditions, and to allow for additional controls to be put in such a way that it enables other parts of your organization, your digital organization or your developers, to be able to make the changes necessary to meet your mission, but at the same time still maintain that control to hit your confidentiality, your integrity, your availability, and your non-repudiation goals. So what is zero trust? I try to distill it down into a small image, and this is the simplest I was able to find. In the top half of this, you have perimeter defense, which is the common gold standard that you see within many environments. That is where you have a trusted network. In that network, you have your services. If you need to connect to another network, you may have a firewall that you put in between them in order to protect entities in one network from entities in another network. But the problem is that if you end up with an attacker in one of these networks, then there's a lot that they can do there, a lot of damage that can be done. In the zero trust model, instead what we say is, well, what if that network was not trusted? No, it's not implicitly trusted. That doesn't mean the firewalls go away. It doesn't mean that you're not trying to protect the network, but it means you're no longer saying this network is the implicit thing in which we base our trust. So once you no longer trust your network, then you have to look at where you push the controls, and the controls end up being at the services themselves. So if you look at the bottom half of this, you can see every service, when it connects to something else, has some form of a something resembling a firewall, something that is a control that that allows you to determine what do you want to send over those links to those other devices. If an attacker enters into your network, again, that doesn't mean you're no longer at risk, but it's yet another layer of security that you have that doesn't allow for implicit access to things simply because they're on the network. So to build our Zero Trust framework, we started with 3 main foundations. This is identity, policy, and automation. Identity is what is it that identifies your service? What is it that identifies your user or identifies your data? How do you know that what you're looking at is the thing that you're looking for? How do you attest that identity? Policy is how do you develop the rules and apply those rules and enforce those rules across identity? From the automation perspective is how do we take this from, let's say you have a single system and you can put a person on that system to defend it. When you start to try to scale this out to a large number of systems, hundreds of systems, thousands of systems, tens of thousands of systems, you need to have automation in place that is able to help you assign the identity and enforce the policy, but also bring in things like observability so you can audit what's going on and to have controls over what the automation is capable of doing or what it's not able to do. So it ends up being 3 intertwined primary pillars that have to be put together in order to build a Zero Trust framework. So we've been working on a reference implementation for this in the cloud native environment, and we focus around 3 primary things. So if you notice, in the triangle, I actually made them link up so you can see identity. We're using Spiffy and Spire. For policy, we're using Open Policy Agent. For automation, we're relying heavily on things like Network Service Mesh. Now, these aren't the only things in the infrastructure, but they're representative of the type of things that we're trying to accomplish. So we'll go over each of these in more detail soon. We also build this on top of Kubernetes. We build it on top of systems like OpenShift. We build in automation on the infrastructure side. We have GitOps style processes that we're bringing in, and underpinning all of this, you still need observability across the whole stack. You still need control over the whole stack. So it ends up becoming this model that this particular thing represents, that all works in coordination to deliver the infrastructure that is part of HealthOS. So what Spiffy and Spire are is they provide identities to your workloads. So most people are familiar with user identity. You put in your password, you log into an online service, you have that user identity. In this scenario, we're looking at workload identities. So every workload receives an X509 certificate. This is the same type of certificate that when you log into your bank will use an X509 certificate to identify who it is. So we're relying on the same type of primitives and principles in order to secure the workloads. When a workload connects to another, they use a new feature within TLS that is available in TLS 1.3 and presumably above as those are released, and that is mutual TLS. Mutual TLS is where your client is able to validate your server like you typically can from a web browser validating your bank, but simultaneously, the server is capable of validating the identity of the client. So you have this two-way validation that occurs within a trust domain. So we're able to create these identities that live within a trust domain that allow them to establish their identities. And these identities are constantly rotated out. Every hour they get rotated out, and by default, if you're using Spiffy and Spire. And every time that you assign a new certificate, you perform a verifiable attestation. And what we mean by that is that the system will ask for an identity. We will look at the properties of that system. You might have a TPM module that you're working with. You might have a identity document that is within AWS or within GCP or other similar systems that have some cryptographic material inside of them that help prove something about that system. So we are able to build our Spiffy identities with attestation that is rooted in these cryptographic materials from these type of systems. This also has a very nice effect because since we're performing this mutual attestation and validation between systems, in many scenarios, it reduces or also eliminates the need for long-living bearer tokens. So in other words, you don't need to pass in a secret. The fact you're connecting in with a specific identity is enough for the system to recognize what type of a system it is and what type of policies need to be applied. In terms of policy, we're looking at things like Open Policy Agent. And Open Policy Agent allows you to consume the identities that are produced by a system like SPIFFE and Spire, and allows you to decide what is this system allowed to do. What are its capabilities that it is able to fulfill. And when you create these particular systems, the properties we're looking for that led us to Open Policy Agent is it has to be something that's human readable, has to be something that meets the look and shape of common policy. So in other words, you could have, how do you classify data? How do you classify workloads? How can you say this system has PHI and create defaults that say don't allow them to connect to systems that don't have PHI or vice versa? And then from there, we can carve out patterns that the system is allowed to perform. In this example, we took this from openpolicyagent.org. So it's one of their examples they have on their front webpage. And you can see a request that says pet owners are allowed with a specific ID that is verified by the JWT, which is something that identifies the user cryptographically, is allowed to receive information or is allowed to make a request against this API in a specific way, if and only if the request comes from, like say this is in front of a database, if and only if the request comes from a client or a workload that we have identified. So it gives us a lot of flexibility to define the exact type of shape and policies that we want in a human readable way that also allows us to get this policy into Git. It allows us to have code reviews on these policies, to share them with other stakeholders so we can get their opinions on whether this policy meets their requirements or not. And it gives us that change over time so we can see how the policy has changed, when did it change, because it's all checked into Git. We also rely on a new technology called Network Service Mesh. Network Service Mesh is another CNCF project that is looking to automate low-level networking systems. So we're looking at, if you're familiar with the OSI model, we're looking at layer 2, layer 3. We're looking at frames in Ethernet and IP and other similar level areas. And what it does is it facilitates the underlay to services. So typically when you're running in Kubernetes, you'll often have multiple clusters you want to connect together in some way. And when you connect them, the assumption is there's already connectivity established between both systems. What Network Service Mesh allows you to do is to acknowledge that there may not be a connection that's there, and you may need certain things in place in order to make that connection work. So this allows the operator to say, in order for this connection to occur, I needed to have a firewall, an intrusion detection system, needs to go through a certain VPN gateway, a certain VPN concentrator. So Network Service Mesh allows you to automate these processes through a cloud-native API with native support from SPIFFE and Spire and Open Policy Agent. And it provides you a cryptographic non-repudiation of that connection chain. So in other words, in this example, we have on the left, HealthOS app going through a specific VPN gateway to a specific VPN concentrator to a specific health app. We can get the cryptographic identity of everything in between and see what is the system connecting through. Is it connecting through systems that we trust? Is it connecting through systems that are required to? Do we have everything in here that we need in order to establish the connection by policy and enforce it on an ongoing basis? Finally, we look at GitOps. And from a GitOps perspective, the workflow, this is more of a process side that is then committed in as a service. So from the process, you have a developer. Developer will make some form of a commit into the source code system, such as Git. Then the CI/CD system, your continuous integration system, will see those changes that have been put into Git and will then render them into your test environment, into your staging environment, your production environment. every change goes through source control. Every change goes through Git, which gives us that auditability. It gives us that chain as to who made the change. We also have control from the QA side. So, in fact, when you're looking at regulatory concerns in this space, it's important that your developers are not allowed to push into production. You have to have a separate group of people, a separate team that is able to look at what changes are there and decide whether or not those changes should hit production. So when you start looking at things that are PCI compliance or HIPAA compliance systems, you tend to see this pattern quite common, so that you don't have a single place or a single person who is able to push these type of things in. So the QA team is then able to determine at what rate and when something is promoted from testing to staging or staging to production. A really great example of a system that you can use to achieve this in your own infrastructure is Flux. So highly recommend that you go look at Flux and give it a try. It hooks up to GitHub and gives you that initial path towards automating in this style. So with that, I want to thank you all for joining us and learning a little bit about Health OS and Zero Trust. Please consider that these are the type of technologies that we're using. We're using OpenShift with Kubernetes. We're using Spiffy and Spire, Open Policy Agent, Network Service Mesh Envoy. Please join these particular communities. There's a lot of things that you can work on in those particular spaces. And if you're interested in the type of things that we're working at, please reach out to either Bobby or I, and we'll help you navigate the path, whether it's coming to work with us directly or whether it's trying to work in the same area in your own industry. So please come and join us. With that, we have time for questions, and thank you very much.
Well, hello all, and let's see if we can get ourselves unmuted. There we go. Bobby, there you are. Stu, I hear track 2 has ended successfully. Thank you very much for that. We have a bit of time left here before the clock runs out on us. So I'd be curious, Frederick and Bobby, I know I had asked you earlier, there is not quite yet a landing page for Health OS anywhere itself. How can people get in touch with you if they're interested in this initiative and get going here?
So there's multiple ways to get in touch with us, but Frederick, why don't you start with look at the open source? It depends on the level of interest. Where are you interested in working, and what is it that you're interested in learning more about? So Frederick, do you want to start with the open source, and then I can talk about the other pieces?
Sure. So in the open source space, there's a few communities that have been focusing on building the core components. So starting from the top, we have Spiffy and Spire. If you go to spiffy.io, there's a range of places where you can interact, including GitHub. There's a Slack channel and all of these have their own Slack channels as well. And there's also, in the policy side, there's Open Policy Agent, which I believe is openpolicyagent.org. Network Service Mesh is another community which is focusing on the automation of the layer 2, layer 3 components that you saw, which is networkservicemesh.io. And we also have the broader communities as well, such as Kubernetes, CNCF, and the OpenShift Commons that you can join in and help in the various levels. And there's also a variety of other downstream communities that are consumed. So, for example, in Network Service Mesh, there is now support for WireGuard, and WireGuard has its own community that's attached there as well. So there's a lot of different places where people can focus on helping at a variety of different levels. If you're interested in the open source area and you're feeling overwhelmed with like where to get involved, or you want to know, like based on your use case, if in the context of Zero Trust, where a good place to start would be, like don't hesitate to reach out to me, and I'm also happy to help guide you through with introductions or meeting people as well. So we want people to get involved.
And if your interest isn't in maybe specific one of those areas, and you've got a use case, or you want to learn more about what we're doing, to Frederick's point, you can reach out to us, connect with us. We're happy to have conversations, talk about where people fit in. We're looking for people and want to work with people that are mission driven, because this work is not easy. Changes, as we saw in the previous few examples, presentations, change is difficult. I know we kind of glossed over that. We're at the end of a change process, but change is tough when we're in the middle of a transformation. So mission driven and people that you are committed to the journey is what we're looking for, and we'd be happy to chat with you about it.
Awesome. Well, I did mention, I did notice a mention of GitOps in your presentation, and yesterday's conference, was GitOps Con. I'm not sure if any of you attended that are in the chat, but I'm wondering, Bobby, if you can talk a little bit about where you are in the journey around GitOps at Anthem, because I think that's top of mind for a lot of us. So
I've been in other paths and other history. So we haven't always had the luxury of starting with greenfield. In most of my career, we've started with legacy applications or applications that existed before I was part of the team. In this case for HealthOS, we were able to start, it was greenfield in the spaces that we were working with in the area. So we are complete cloud native. And so we had a great chance to just start foundationally. One of the first teams we built was our DevOps or GitOps team. And we started with automation in mind. So our CI/CD pipeline is continuous. The D part isn't, CD isn't something that we subscribe to, but we went from releases that were once a quarter to now we are down to they're big feature releases, because it's a platform, and when you release, you have to be careful what you're putting out there. But some of our teams are now releasing monthly, and then we've got actually one team that is releasing 7 to 10 times a week through their GitOps pipeline, their CI/CD pipeline. So it's been interesting. It's been a journey in automation. Things don't always work the way that you would want them to or imagine them to. So we engineer around them, but it's taken some resilience, and we're thankful for those tools. But we also want them to get better. That's another way to say it. We want them to get better. And one of the places that we have struggled is that in the management console space, in this, and just creating awareness around the clock. So when something isn't going to work or something's has failed, that we're the first to know. And that's been a lot of our focus. It's not just getting the pipeline, but it's the monitoring of the pipeline, so that we can. Every event is becoming less and less an event. Every push becomes less and less event, and it's scriptable. And we also look for tools where we can script, and it's not manual intervention and typing in IP numbers to whatever else you might imagine. So it's been a journey, and we'd love to showcase it at some point, show you how we're doing it.
Oh, well, we'll definitely give you the podium to do that again, because I think that sharing of those stories, improving the tools, those are all really what we're here about today, trying to make sure it happens. And your feedback is sort of essential. And I know, like, especially with the GitOps stuff and the stuff that we're doing here at Red Hat and in the open source world, that's been top of mind for a lot of stuff. The monitoring and the notification pieces are essential. So Frederick, any final words of wisdom? I know we've had you on many times before, and it's always interesting, and it's always kind of bleeding edge stuff that you kind of bring us to. And are there any things going on at KubeCon, since that's first of mine here too, that we ought to be watching for?
So yeah, KubeCon is quite an event. I know it's still pretty hard to do some of the engagement because of COVID-19. Highly recommend, if you're not on any of the Slack channels, get on them. People are on them all the time. They have a set of channels that are related towards KubeCon, and if you want to meet people and have conversations, strongly recommend that you hop on and just say, hey, I want to talk about zero trust, and jump into the appropriate channel, or I want to talk to the people from Spiffy or OPA or similar, and find the room that has the most people in that has adjacent relations to those topics, and just ask away and see who answers, and establish some form of communication with them.
Yeah.
We don't have those hallway tracks anymore right now, at least not until the next one. And the hallway tracks are one of the most important parts of KubeCon. So we need to find ways to work around the issue. Other than that, there's a lot of really amazing talks. There always are. It just depends entirely on your interest. So definitely find the ones that interest you.
I think that was some of the best advice too, is like the Slack channels around KubeCon. If you're in the Kubernetes Slack and the OpenShift users, or the OpenShift dev Slack as well, channels there are really pretty key. And if you're not yet an OpenShift Commons member, you can always go to commons.openshift.org and fill out the little form there, and we'll onboard you into yet another Slack channel, OpenShift Commons, which is where Frederick and I and others hang out and chat all the time. And it's a great way to meet people who are doing these things inside of OpenShift. But all of it's being done in the open. So please do reach out, connect with your peers, and definitely keep us involved, Bobby, in the Health OS stuff. We'll definitely put you back on stage and give you a venue. All of the talks from today will be now published via YouTube shortly, and we'll tweet out a little notice that they're all live. And I wanted to take a moment and say what Stu has probably been saying all day long. May the 4th be with you all. Thank you for sharing May the 4th with us. It's been a very Star Wars kind of interesting day for us on the main stage. Quite a few little glitches there, here and there, but thanks for sticking with us. We really appreciate it. We so appreciate having end users come and talk about these technologies rather than having Red Hatters talk about it. It's wonderful to hear it from the people who are actually on the front lines using the stuff. And what I'm really loving about today is how many of the end users, people like Bobby and Frederick and Solis from Six and everybody else and the folks from Discover, and I think you saw Stu in your track, the folks who are working in the open source now. I think that's the really big change that we're all seeing, is how many more of our end user organizations are now participating out there in the open and working on and contributing directly to these projects and driving a lot of them. So I think that's really the big change in open source for us. It's not really as much of a vendor-driven space as it was in the past, though all of us vendors are out there and contributing too. You heard from Clayton and all the folks talking about the different projects that Red Hatters are involved in. So there's plenty of us out there, but there's even more end users now getting involved and kicking off new initiatives. And, Health OS, for example, about every single time we host a gathering, the last time it was the Enterprise Neuro Systems AI Ops in the telco space, they had their foundation and they were all coalescing around that. It's an amazing world out there right now. And I'm really grateful for everybody for sharing their stories and their contributions. It's always enlightening and much more interesting than hearing me blather on. And Stu, as always, you're new to this game in the Commons. You've been doing the Cube and all kinds of other things and market insights. Thanks. Any final words from the Star Wars fan that you are?
Well, Diane, hey, it was great to be a part of this. Always loved going to KubeCon, as you said, that kind of user-created and collaboration. So many of the projects out there was, I had a challenge, nothing existed. I created something, found out other people had the same problems. Listening to like the Argo CD, it's like, oh, hey, Intuit, let's hear what they had. I had interviewed them, back in the past. So that co-creation, loved all the sessions over on track 2. Especially Diane, I know you've got a special place in your heart for the OKD content there. So that was a really good discussion of just how much effort and work and giving back eventually before they got things in production. So had a lot of fun over there. And yeah, had some good Star Wars humor as part of it too. As the joke is, most people are like, hey, today's Star Wars Day. In my household, it's Star Wars Day every day. So
yeah. Well, it was the Red Hat version of the Darth Vader maps behind you. That was really the thing that got me going when we first started talking about all this. So I'm totally grateful. I can't wait till we can all be back in person again. And a huge shout out to everybody, Chris Short, who's out there still streaming on OpenShift TV for us and producing us in the back. I'm really grateful for that support. And now we have 3 more days of KubeCon. And KubeCon is rolling behind us in the background as well. So jump into those KubeCon Slack channels, look for us in the Red Hat Expo booth or whatever it is that they set up for us, and we'll be taking your questions there. And if you're interested in having the podium, my favorite thing to do is make other people talk. So if you have a talk or a project or a tech initiative that you're looking to get some awareness of, please reach out to us and we'll definitely give away the podium. That is the whole point of OpenShift Commons. It's all about the end users and getting everybody connected. So once again, thank you all, Frederick and Bobby and Stu, for all your efforts today. Totally appreciate it. Now, it is now officially 7 a.m. where I am. So I am going to get another cup of coffee and try and stay awake for the rest of today. So thanks, guys. Much, much appreciated.